Now we are going to solve another question. See the question here. If x of z is the z transform of x of n, which is equal to half into the power of mod of n, then the ROC of the x of z is. So basically, in the question, they are given that x of z is called as z transform of the signal x of n, where x of n is equal to half of all the power of mod of n. Then what is the ROC of the signal? We need to figure out. See, out of the four options, option C, which is half less than mod z less than 2. This mod z is going to lie between half and 2. Is the correct solution of this question. So let's solve this numerical. So in the question what they are given? They are given x of n, which is equal to half on the power of mod of n. So for the signal, what is the ROC that we need to figure out? So mod of n is nothing but displacement for n greater than or equal to 0 and is equal to minus n for n less than or equal to 0. So therefore we can say mod n is equal to plus n for n greater than or equal to 0 and so is equal to minus n for n less than or equal to 0. And what is x of n? I can write half over the power of n into u of n plus half over the power of minus n into u of minus n minus 1. So this is what we can write. Mod of n half the power of mod n. We can write like this. Half the power of n into u of n plus half the power of minus n into u of minus n minus 1. So like this we can write this signal. So this signal we are going to write like this. So let me write here so that you can easily able to understand. So half the power of mod n. Now we can write half into u of half to the power of n into u of n plus half to the power of minus n into u of minus n minus 1. So like this we can write it. So this signal is defined from 0 to infinity and this signal is defined from which is minus 1 to minus infinity. So or you can write minus infinity minus 1 also we can write here. So let me write this part. So therefore we can say, so let me write this part so that we can easily able to understand. So now as you can see clearly half to the power of mod n we can write half to the power of n into u of n. This is defined from n is equal to 0 to n is equal to infinity. And half the power of minus n into u of minus n minus 1. This is defined from n is equal to minus infinity to minus 1. So like this we can write here, right? So now same thing we have written here. So x of n is equal to half to the power of n into u of n plus this I can write to the power of 1 by 2 I can write to the power of minus 1. To the power of minus 1 and the power of minus 1 n is nothing but, so I can write like this, right? To the power of minus 1 over to the power of minus n means to the power of minus 1 into minus n is plus n to the power of n. So to the power of n into u of minus 1 minus n minus 1. Same thing I am written in different fashion. So this is u of n is nothing but we can say this is a right side signal. It's a right sided signal because the signal is 0 for n less than 0. So the signal is equal to 0 for n less than 0. So we can say this is a right sided signal. So right sided signal. So what is the ROC? The ROC is nothing but simply see as I already told you, add the power of n into u of n. The ROC is mod z greater than mod n. So mod z greater than mod n. Mod is nothing but half. Mod of half, which is nothing but half. So ROC is equal to mod z greater than half. Similarly, to the power of n into u of minus 1 minus n minus 1, which is a left side signal because the signal is equal to 0 for n greater than 0. So the signal is equal to 0 for n greater than 0. So therefore we can say this is the left side signal. So what is the ROC? And it's a left side signal. So what is the ROC? Mod z less than mod a. Where a is nothing but 2. So mod is nothing but mod 2. So mod z less than 2. So therefore we can say this is nothing but I already told you the formula. For a to the power of n into u of n, the z transform is z by z minus 0 with an ROC mod z greater than mod a, where a can be positive or a can be negative. Similarly, mod z minus a to the power of n into u of minus 1 minus n with a z transform z by z minus a with an ROC mod z less than mod a. So this one I have already told you so many number of times. This two formulas always you have to keep in your mind. So for e to the power of n into u of n, z transform z by z minus a, and with ROC mod z greater than mod a, and minus into e to the power of n into u of minus n minus 1 as the ROC z by z minus a, with an ROC module less than mod A. Here outside the circle and this is the inside the circle. This is a right signal signal, so ROC is outward. This is a left signal signal, so ROC is inward. So from this what we can say simply, so this is a right signal signal. So its ROC is module bigger than mod A. And this is left signal signal, so its ROC is module less than mod A. Here A is nothing but half and here A is nothing but 2. So here module less than half, here module greater than 2. Sorry, here module greater than half and here module less than 2. So now what is the net ROC? If you want the jet transform to exist for the signal X of n, the ROC is the common ROC. What is the common ROC? The common ROC is nothing but the ROC line between the half as well as 2. The net ROC of the common ROC, which is the intersection of these two ROCs, which is module greater than half and module less than 2. So what is the net ROC? It is going to lie between half as well as 2. Half as well as 2. So therefore, what suppose if they ask you the jet transform? What is the jet transform? This I already told you. Take the power of n into u of n as jet transform, jet by z minus a. With an ROC module greater than mod A, it can be positive or it can be negative or it can be complex number. Similarly, minus into the power of n into u of minus n minus 1 as jet transform, jet by z minus a with an ROC module less than mod A. Where A can be positive, A can be negative, or A can be a complex number. Suppose if I multiply minus on the both sides, then what I am going to get? Here, take the power of n into u of minus n minus 1 at z transform minus z by z minus a. The ROC is same, which is mod z less than mod A. Where A can be a positive, A can be negative, or A can be a complex number. So if you see, this is in this fashion and this is in this fashion. So therefore, what is the z transform with z by z minus a? It is equal to r. So z by z minus a is equal to r. And this is something that in this fashion we can say a is equal to 2, a is equal to 2, and also then minus z by z minus a, which is minus z by z minus 2. So this is the net jet transform for the signal X of n. So what is the common ROC? The common ROC is the intersection of the individual ROC. So common ROC or the net ROC is the intersection of both the ROCs. It is half less than mod jet less than 2. Then net ROC is mod is going to lie between half as well as 2. So if I am going to draw in the jet plane, so this is the, we can say half circle of radius half. It's a circle of radius half and a circle of radius 2. So this half is nothing but is the right side signal. It is going outward. And this 2 is nothing but it's a left side signal. So coming inward. So what is the common ROC? This is the common ROC. So this is the common ROC. Intersection of these two also nothing but this is the common ROC. So only for each and every value in this value of z, then only you are going to get finite value. So this X of z is going to define only for this range of z, only for these values of z in this region, we are going to get a finite value. So that is called as the ROC. So therefore we can say, if you substitute any value in this region of ROC, then we are going to get a finite value. So therefore it is the reason it is called as ROC. So therefore the ROC of X of z is nothing but half less than mod z less than 3. So this one I already told you that for n the power of n into u of n, z transform z by z minus a, and it is a right signal signal. So its ROC is mod z than mod a. A can be positive, A can be negative, A can be complex. Similarly, minus into n the power of n into u of minus 1 minus n minus 1 at z transform z by z minus a with an ROC mod z less than mod a, because here it is a left signal signal, so ROC is inward. A can be positive, A can be negative, A can be complex. If you multiply minus on both sides, then we are going to get a the power of n into u of minus n minus 1 and z transform minus z by z minus a. The ROC same, which is as it is. Is mod z less than mod a. A can be positive, A can be negative, A can be complex, and it is a left side signal. So ROC is inward. ROC is inward. So now we will discuss some more important points regarding the signal and the nature of the ROC. The nature of the ROC is a very important point I am going to discuss. See, why I am going to discuss this point, I will tell you later. We are to listen the concept. So this is the signal and this is the nature of the ROC in the jet plane. So this is the nature of the ROC. So let me write here. I think it is not visible. So this is the nature of the ROC. So nature of the ROC in the jet plane. In the jet plane. So let me write this one. Right-sided signal. So suppose if a given signal is a right-sided signal, then the nature of the ROC is outward of a circle. The given signal is a left-sided signal, then the ROC is inward of a circle. The given signal is a considered signal and the ROC is an annual strip. The given signal is a finite time duration signal. So finite time duration signal. Let me write a finite time duration signal. Then the ROC can be all over the display except point circle or input circle or both. So finite time duration signal means the ROC can be all over the display, all over the jet plane except point circle or input circle or both. So in the question, the given signal is a two-sided signal. So its ROC is the angular strip. So by elevation technique in option also we can solve. So basically, if you see clearly, this signal is a two-sided signal. Two-sided signal means the signal is present for all values of n. So therefore we can say this is a two-sided signal. As it's a two-sided signal, so what is the nature of the ROC? The nature of the ROC is the angular strip. It is going to lie between the two circles. So here it is outward of a circle, is inward of a circle. Only here the ROC is going to lie between the two angle strips. So this is the correct solution. So if you know the nature of the signal, just by seeing the options, we can tell which is the option is the correct. So whereas is the entire jet plane, it cannot be possible. So only four option C is the correct solution of this question. Just by seeing the nature of the signal, we can comment on the ROC also. So therefore we can say as the given signal is a two-sided signal because the signal is present for all values of n. So by default, ROC is the angular strip. It is going to lie between the two circles. So that is satisfied only in the case of the option C. So by elimination also we can solve this question in a very fraction of second. So let me tell you what is the meaning of right-sided signal, left-sided signal, two-sided signal and the finite time duration signal. See, if f of t is equal to 0 for t less than 0, then we say it is the right-sided signal. If f of t is equal to 0 for t greater than 0, then we say it is a left-sided signal. If f of t is not equal to 0 for all values of t, then we say it is a two-sided signal. If f of t is not equal to 0 for only a certain duration of time from t1 to t2 and its value is equal to 0 otherwise, then we say it is a finite time duration signal. So listen carefully. Finally, I can say if f of t is equal to 0 for t less than 0, then we say it is a right-sided signal. If f of t is equal to 0 for t greater than 0, then we say it's a left-sided signal. And if f of t is not equal to 0 for all values of t time, then we say it is a two-sided signal. And if f of t is not equal to 0 for certain values of time from t1 to t2 and its value is equal to 0 otherwise, then we say it is a finite time duration signal. So for a finite time duration signal, the ROC can be all over the jet plane except point circle or input circle or both, depending on the conditions. Depending on the conditions, as I already told you, respond so many number of times. So these things always you have to keep in mind here. So finally, option C is the correct solution of this question. So option C is the correct solution of this question. So now we are going to solve the other question. See the question here. In a linear phase system, PG, the group delay, and PP, the phase delay are. So in a linear phase system, PG, the group delay, and PP, the phase delay are. So in the question what they are asking is in a linear phase system, PG is called as a group delay and the PP is called as a phase delay. So we have to comment on the nature of these two things. So the four options, option A, they are constant and they are equal to each other. So for a linear phase system, PG and PP both are constant values and they are equal to each other. So now we'll discuss why option is the correct solution of this question. So let's solve this numerical. So now h of omega is equal to y of omega by x of omega. So suppose if you take some system, if you take some LTI system, linear, I can say LTI system, it's a linear time invariant system, where input is x of omega and the output is y of omega, and this is h of omega. So y of omega is equal to x of omega into h of omega. So h of omega is equal to y of omega by x of omega. PP is called as a phase delay of the system. Phase delay of the system, and PG is called as the group delay of the system. The shortcut remember is PG. I already told you post graduation. Post graduation, I already told you. PG is post graduation is PP and PG. So PP and PG. PP is called the phase delay of the system and PG is called the group delay of the system. So PP is equal to minus of delta of the phase angle of h of omega by omega. And Tg is equal to minus d by d omega of phase angle of h of omega. So these formulas I already told you. TP is called as a phase delay of the system and TD is called as a group delay of the system. The TP is equal to minus of phase angle of h of omega by omega, and TG is equal to minus V by d omega of phase angle of h of omega. TP is called as the phase delay of the system and TG is called as the group delay of the system. So this point you have to keep in the mind. So TP is equal to minus phase angle of h of omega by omega, and TG is equal to minus V by d omega of phase angle of h of omega. So TP is called as the phase delay of the system and TG is called as the group delay of the system. So with the shortcut name is PG. Post graduation. So first P you are going to get, then G you are going to get. So for a linear phase system, what is going to get happen? Listen carefully. For a linear phase system, what is going to happen now? We'll discuss. Suppose it is a linear phase system or LTI system. The input is f of t. For this LTI system, the linear phase LTI system, and we have to assume the impulse response is A into delta of t minus t naught. The impulse response is h of t is equal to A into delta of t minus t naught. Then what is the output that we are going to get? Y of t is equal to f of t convolution of h of t. When A is a constant, we can take it outside. So f of t convolution of delta of t minus t naught is equal to f of t minus t naught. So y of t is equal to A into f of t minus t naught. So if I am going to apply the Fourier transform for all the signals, then what we are going to get? This will become f of omega, this will become h of omega, and this will become y of omega. So y of omega is equal to, so the y of t is nothing but f of t convolution of h of t. So y of omega is equal to f of omega into h of omega. But y of t is equal to A into f of t minus t naught. So if you apply the Fourier transform of both sides, then what we are going to get? Y of omega is equal to A into f of omega into e to the power of minus j omega t naught. As I already told you, this form is shown a number of times, but let me tell you. So for f of t, the Laplace transform is f of s. Then for f of t minus a, the Laplace transform is e to the power of minus as into f of s. Suppose if you want Fourier transform is replace s by j omega. So minus a j omega f of omega. So what you are going to get? Suppose A is nothing that I am going to assume this is t naught. If I assume A is equal to t naught, then what you are going to get? Then you are going to get e to the power of t naught omega j f of omega. So e to the power of minus omega t naught j f of omega. Same thing. A into e to the power of minus j omega t naught. You can write it any fashion. Any the concept is same, right? Same thing like that. E to the power of minus j omega t naught into f of omega. So what we are going to get? A into f of omega into e to the power of minus j omega t naught. Fourier transform. So what is h of omega? H of omega is nothing but y of omega by f of omega. So and what is y of omega by f of omega? Is A into e to the power of minus j omega t naught. A into e to the power of minus j omega t naught. So what is h of omega? H of omega is equal to A into e to the power of minus j omega t naught. Then what is mod of h of omega, which is A, and the phase angle of h of omega is nothing but minus omega t naught. So this is a complex number, so you can write in the polar format, which is A and the phase angle of minus omega t naught. The magnetic value is equal to A, and the phase angle value is equal to minus omega t naught. So I want to only the phase angle part. In the phase angle part, I want to write. So the phase angle of h of omega is equal to minus omega t naught, and the magnitude of the h of omega is equal to A. That is what I have written here. So for a linear phase system, the phase angle of h of omega is equal to minus omega t naught, and the magnitude of the h of omega is equal to A. Then what is the phase delay of the system? P2 is equal to minus of phase angle of h of omega by omega. So minus of phase angle of h of omega is equal to minus omega t naught. So minus omega t naught by omega. So minus 2 minus is plus. So omega cancels, we are going to get 2. What is Tg? Tg is equal to minus d by d omega of phase angle of h of omega. So minus d by d omega of phase angle of h of omega is nothing but minus omega t naught. Minus omega t naught. So minus 2 minus is positive. So as we are doing with respect to omega, so t naught is a constant, we can take it outside. So t naught into d by d omega of omega is nothing but 1. So you are going to get final t naught into 1 is equal to t naught, you are going to get. So you are going to get its value is equal to t naught. So phase time is equal to t naught and group time is also equal to t naught. So both are equal and both are constant. So that is a constant value. It's a constant value for a given system. So P2 is equal to Pg is equal to t naught. So both are equal and they are equal to a constant value. So in the case of the linear phase system, both the phase delay and the group delay both are equal and they are going to equal to a constant value. So this one you have to keep in your mind. So therefore we can say that for a linear phase system, you have to keep in your mind. The only thing that I wanted to remember for a linear phase system, I wanted to remember only these three important formulas. For a linear phase system, the phase angle of h of omega is equal to minus omega t naught, and the phase delay time is equal to minus of phase angle of h of omega by omega, and the group delay time is equal to minus d by d omega of phase angle of h of omega. So if you remember these things, everything is simple. So in the case of linear phase system, both the phase time and the group time both are equal and are equal to constant value. So therefore, this is the correct solution for this question. So the linear phase system, Pg and Qp both are equal to each other and they are equal to constant value. So this is the correct solution of this question. So Pg is a group delay and Qp is called as a phase delay of the system. So this is the correct solution of this question. Now we are going to solve the other question. See the question here. If the minimum sampling frequency required to reconstruct a band-limited analog signal from its sample is 8 kHz, the maximum frequency present in the signal is. So in the question they are saying that if the minimum sampling frequency required to reconstruct a band-limited analog signal from its samples is 8 kHz, the maximum frequency present in the signal is. So in this question they are saying that the minimum sampling frequency is 8 kHz. Then what is the maximum frequency which is present in the signal? We need to figure out. Band limited means it has a range of frequencies from 0 to FM, where FM is called as the maximum frequency which is going to present in the signal. So we have to find what is the maximum frequency present in the signal. We need to figure out. So the four options, option A, 4 kHz is the correct solution of this question. So let's solve this numerical. See, as I've already told you, what is the important point? The important point is very simple, which is the minimum sampling frequency. So what is the minimum sampling frequency? Already they have given. The minimum sampling frequency is nothing but it is 8 kHz. The minimum sampling frequency is nothing but 8 kHz already they have given. So we have to find what is the maximum frequency present in the signal. FM is also called as the maximum frequency which is going to present in the signal. I have already told you the sampling frequency should be always greater than or equal to 2 times the message signal frequency, where FM is called as a maximum frequency which is going to available in the signal. Right? The sampling frequency should be always greater than or equal to 2 times the message signal frequency, where message signal frequency is it is nothing but the maximum frequency, which is going to present in the signal. So this is a condition for no aliasing. So what is the minimum sampling frequency, which is equal to 2 into FM max. So already they know what is the minimum sampling frequency. 8 kHz is equal to 2 into message signal maximum frequency. So 8 by 2 is nothing but 4. So 4 kHz. So therefore the maximum frequency which is going to present in the signal is nothing but 4 kHz. So always you have to keep in your mind, which is the sampling frequency. The sampling frequency is always greater than or equal to 2 times the message signal frequency. This message signal frequency is nothing but it is the maximum frequency which is going to present in the signal. When FM is nothing but it is the maximum frequency which is going to present in the signal. So Fs minimum is equal to 2 into FM, where FM is the maximum frequency present in the signal. So Fs minimum we know, and divide by 2, then we are going to get the maximum frequency which is going to present in the signal, which is equal to 4 kHz. So always the sampling frequency is always greater than or equal to 2 times the message signal frequency for no aliasing. For no aliasing means no overlapping. So therefore we can reconstruct the original signal from its sample. So 4 kHz is the correct solution of this question. So now we are going to solve the other question. See the question here. The convolution of the x of t plus 5 with the impulse function delta of t minus 7 is equal to. The convolution of x of t plus 5 with the impulse function delta of t minus 7 is equal to. So basically in this question they are asking what is the convolution of the x of t plus 5 with the impulse function delta of t minus 7. They are asking this question. So what is the convolution of the x of t plus 5 with the delta of t minus 7? They are asking this question. So what are the four options? Option A, x of t minus 2 is the correct solution of this question. So let's solve this numerical. See See, basically, as I've already told you one important formula. Suppose if we know that f of t, convolution of the delta of t is nothing but f of t. This formula is already told you. So f of t convolution of delta of t is nothing but f of t. Similarly, f of t minus t1 convolution of delta of t minus t2 is equal to f of t minus of t1 plus t2. So this is the general formula as I've already told you so many number of times. So if f of t convolution of delta of t is equal to f of t, then f of t minus t1 convolution of delta of t minus t2 is equal to f of t minus of t1 plus t2. So by using this formula, we are going to solve this question. So now, what they are given? X of t plus 5. So x of t plus 5 means I can write x of t minus of minus 5. Convolution of delta of t minus 7. So x of t minus of minus 5. Convolution of delta of t minus 7 is nothing but x of t minus of minus 5 plus 7. So minus 5 plus 7 is nothing but plus 2. So t minus 2. So therefore x of t minus 2 is the resultant solution that we are going to get. So x of t plus 5 convolution of the delta of t minus 7 is equal to x of t minus 2. So you have to remember this formula, which is f of t convolution of the delta of t is equal to f of t. So f of t minus t1 convolution of delta of t minus t2 is equal to f of t minus of t1 plus t2. So if you remember the formula, if you remember the statement, it is very easy to solve these type of questions in a very fraction of second. So if f of t convolution of delta of t is equal to f of t, then f of t minus t1 convolution of delta of t minus t2 is equal to f of t minus of t1 plus t2. So by using this formula, we have solved this question, and this is the correct solution of this question. So now we are going to solve the another question. See the question here. The inverse Fourier transform of the signal. The inverse Fourier transform of the signal x of j omega is equal to 2 pi delta of omega plus pi into delta of omega minus 4 pi plus pi into delta of omega plus 4 pi. So basically they are given a Fourier transform of a signal, and they're asking what is the inverse Fourier transform is a time domain signal we need to figure out. So basically for a signal, they are given the Fourier transform expression. So now we have to find what is that signal we need to figure out. So what is the signal expression that we need to figure out? So what are the four options? Option A is the correct solution of this question, which is 1 plus cos 4 pi t is the correct solution of this question. So 1 plus cos 4 pi t is the correct solution of this question. So let's solve this numerical. So now already they are given the Fourier transform of a signal, which is x of j omega is equal to 2 pi into delta of omega plus pi into delta of omega minus 4 pi plus, here I think there is a pi, extra pi also there, right? So here pi, a small correction here, here also pi is there, I am not written. So here pi of delta of omega plus 4 pi is there. So this is a Fourier transform of a signal they have given. So in these two terms I am going to take the pi as a common. Then what I am going to get, x of j omega is equal to 2 pi delta of omega plus pi common, delta of omega minus 4 pi plus delta of omega plus 4 pi. So this is a Fourier transform expression they are given. So now we have to find what is the time domain signal or the inverse Fourier transform for this signal we need to figure out, which is time domain expression we need to figure out. So I have already told you some important formulas. For 1, what is the Fourier transform 2 pi delta of omega? So 1 means what is the Fourier transform 2 pi delta of omega, and cos omega naught t, what is the Fourier transform pi into delta of omega minus omega naught plus delta of omega plus omega naught. Then what is sin omega naught t formula? I have already told you. So these formulas you have to keep in your mind. Sin omega naught t Fourier transform formula is nothing but pi by j into delta of omega minus omega naught minus delta of omega plus omega naught. So this is a formula you have to keep in your mind. So for 1, the Fourier transform is 2 pi into delta of omega, and for cos omega naught t, the Fourier transform is pi into delta of omega minus omega naught plus delta of omega plus omega naught. Sin omega naught t Fourier transform is pi by j into delta of omega minus omega naught minus delta of omega plus omega naught. So now if you see clearly, so 2 pi delta of omega means inverse Fourier transform is 1. Pi delta of omega minus omega is nothing but 4 pi. So what is the inverse Fourier transform? Cos 4 pi t. That's it. So for this one it is 1, and for this one cos 4 pi t. That's it. We have to add. So x of t is equal to 1 plus cos 4 pi t. 4 pi t. So this is the correct solution of this question. So you have to remember, for 1, the Fourier transform is 2 pi delta of omega, And for cos omega naught t, the Fourier transform is pi into delta of omega minus omega naught plus delta of omega plus omega naught. And sin omega naught t, the Fourier transform is pi by j into delta of omega minus omega naught minus delta of omega plus omega naught. So this one you have to keep in your mind. And let me give you some more formulas also that you have to keep in your mind. For one, the Fourier transform is 2 point delta of omega. For cos omega naught t, the Fourier transform is pi into delta of omega minus omega naught plus delta of omega plus omega naught. And for sin omega naught t, the Fourier transform is pi by j into delta of omega minus omega naught minus delta of omega plus omega naught. And for delta of t, the Fourier transform is 1. And for u of t, the Fourier transform is pi into delta of omega plus 1 by j omega. So these formulas always you have to keep in your mind because most of the questions are going to be based on these formulas. So I request you to remember these formulas. So finally I can say for one, the Fourier transform is 2 pi into delta of omega. For cos omega naught t, the Fourier transform is pi into delta of omega minus omega naught plus delta of omega plus omega naught. For sin omega naught t, the Fourier transform is pi by j into delta of omega minus omega naught minus delta of omega plus omega naught. And for delta of t, the Fourier transform is 1. And for u of t, the Fourier transform is pi into delta of omega plus 1 by j omega. So finally, for 1, the Fourier transform is 2 pi into delta of omega. And for cos omega naught t, the Fourier transform is pi into delta of omega minus omega naught plus delta of omega plus omega naught. For sin omega naught t, the Fourier transform is pi by j into delta of omega minus omega naught minus delta of omega plus omega naught. For delta of t, the Fourier transform is 1. And for u of t, the Fourier transform is pi in delta of omega plus 1 by j omega. So pi in delta of omega plus 1 by j omega. Or we can write in the vice versa also. Vice versa means 1 by j omega. So 1 by j omega plus pi into delta of omega also we can write. But I prefer to use only this one because for u of t, the Laplace transform is 1 by s, right? So like that, s is equal to j omega plus some extra factor will be there, just pi in delta of omega. So these things always you have to keep in your mind. So finally I can say for 1, the Fourier transform is 2 by delta of omega. For cos omega naught t, the Fourier transform is pi into delta of omega minus omega naught plus delta of omega plus omega naught. For sin omega naught t, the Fourier transform is pi by j into delta of omega minus omega naught minus delta of omega plus omega naught. Delta of t, the Fourier transform is 1. And for u of t, the Fourier transform is 1 by j omega plus pi into delta of omega. So these things always you have to keep in your mind. Now we are going to solve another question. See the question here. Determine the discrete time Fourier transform for the signal. So we have to determine the discrete time Fourier transform for the signal. X of n is equal to -2, -1, 0, 1, 2. So at n is equal to 0, x value is equal to 0. So these are the negative values of n and these are the positive values of n for which they are going to get the values. So these are the negative values of the n, they have given values, and for the positive values of n, they have given values. The arrow indicates that at origin, this is the value that we are going to get. So for this discrete time signal, we have to find what is the discrete time Fourier transform we need to figure out. So the 4 options, option B is the correct solution of this question, which is -2j into 2 into sin 2 omega plus sin omega. So this is the correct solution of this question. So let's solve this numerical. So as you can see clearly, as I've already told you, for a continuous time signal, we are going to get the continuous time Fourier transform. The discrete time signal, we are going to get the discrete time Fourier transform. Very simple, right? So for a continuous time signal, we are going to get the continuous time Fourier transform, and for discrete time signal, we are going to get the discrete time Fourier transform. So what is the x of n, which is -2, -1, 0, 1, 2. So we have to find the discrete time Fourier transform. So first we will try to get the Z transform. From that we are going to get the discrete time Fourier transform. But I will tell you. So for x of n, what is the Z transform formula? X of z is equal to sigma n is equal to -7 plus n with the x of n into the power of -n. So this is the Z transform of the x of n. This x of z is equal to sigma n is equal to -7 plus n with the x of n into the power of -n. So now, suppose for x of n, if you want to find what is the discrete time Fourier transform, very simple, replace z by e to the power of j omega. So replace j by e to the power of j omega. That's it. Then we are going to get the discrete time Fourier transform, which is wherever z is there, replace z by e to the power of j omega. So x of e to the power of j omega is equal to sigma n is equal to minus 7 plus something x of n into e to the power of j omega to the power of minus n means e to the power of minus j omega n. I have already told you the discrete and Fourier transform is nothing but in z transform replace z by z is equal to 1 into e to the power of j e to the power of j omega or e to the power of j omega, anything you can say. So in the z transform, if you replace z by e to the power of j omega, we are going to get the discrete Fourier transform. So this is the thing that we are going to get, just x of e to the power of j omega is equal to sigma n is equal to minus 7 plus x of n into e to the power of minus j omega n. So now as x of n is having only values from, so this is from 0, minus 1, minus 2, plus 1 and plus 2. So only the values are being from only minus 2 to plus 2. So the remaining values are going to become 0. So this summation is going to become now only from minus 2 to plus 2. So the summation will now converge to only n is equal to minus 2 to plus 2 because the remaining values are 0. So like this we have to solve. So now if you substitute the values, then what we are going to get? If you substitute n is equal to minus 2, then we are going to get x of minus 2 into the power of 2j omega plus, if you substitute n is equal to minus 1, then we are going to get x of minus 1 into the power of j omega plus, now if you substitute n is equal to 0, then we are going to get x of 0 plus, if you substitute n is equal to 1, then we are going to get x of 1 into the power of minus j omega plus, now if you substitute n is equal to 2, then we are going to get x of 2 into the power of minus 2 j omega. So now you know each and every value, right? So what is x of minus 2? X of minus 2 is nothing but minus 2. X of minus 1 is nothing but minus 1. X of 0 is nothing but 0. X of 1 is 1 and x of 2 is 2. So you know all these values I have substituted here, then I got like this. So now what I will do, I will, in this last two terms, I will take 2 as a common, and then I am going to get 2 into e to the power of minus 2j omega minus e to the power of 2j omega plus. So here these two things I am going to write combined. So e to the power of minus j omega minus e to the power of j omega. So now I want to basically simplify this one. So what you are going to get from here? So what you are going to get here? Simply, if you simplify, what you are going to get is very simple. So here, see, I already told you, e to the power of I theta, e to the power of minus I theta minus e to the power of I theta is how much? So you know, this is cos minus sine. So cos cancels, we are going to get minus 2i sine theta you are going to get. So what is theta value? Theta value is nothing but here omega. So minus 2j sine 2 omega into 2 is there plus, and this is also same thing, e to the power of minus I theta minus e to the power of I theta sine, it is nothing but minus 2i sine theta. Theta is equal to omega, so minus 2j sine omega. So if you simplify, if you take this 2 inside, then we are going to get minus 4j sine 2 omega minus 2j sine omega. So in these two things, if you take minus 2j as a common, then we are going to get like this. Minus 2j common means what we are going to get here? 2. So 2 into sine 2 omega plus sine omega. So this is the overall that equation that we are going to get here. So the discrete Fourier transform of this equation is minus 2j into 2 sine 2 omega plus sine omega. So this formula always you have to keep in your mind. So finally, let me give you some important formula that you always have to keep in your mind. So what is the, for a continuous time case, what is the Laplace transform for x of t? What is the Laplace transform, which is x of s is equal to integration of t is equal to minus infinity plus infinity x of t into e to the power of minus st into dt. So if you want to find what is the discrete, say you can say continuous time, this continuous time Fourier transform, then replace s by j omega. That's it. Replace s by j omega. Then you are going to get integration of t is equal to minus to plus infinity x of t into, so x of t into e to the power of minus j omega t into dt. Suppose for discrete time case, so for x of n, what is the discrete time for the z transform, which is x of z is equal to sigma n is equal to minus infinity plus infinity x of n into z to the power of minus n. So for x of n, if you want to find what is the discrete time Fourier transform, then in the place of z, replace z by e to the power of j omega. That's it. Then what we are going to get? We are going to get like this. N is equal to minus infinity plus infinity x to the power of n into e to the power of minus j omega n. So these formulas always go to keep in your mind. So if you want the continuous time Fourier transform is in the place of Laplace transform, replace x by j omega, then we are going to get the continuous time Fourier transform. Similarly, if you want the discrete time Fourier transform, then simply we have to replace z by the e to the power of j omega in the case of the jet transform, then we are going to get the discrete Fourier transform. And I already told you, see, whenever you are going to compare these two things, so whenever we are going to compare these two things, I can say by comparing the integration is now become summation. T is now T now it became n, and then we can say, so if we can write like this, right? Here e to the power of s I can take common and over the power of minus t, right? I can write like this. So I can write like this, right? So let me write here. So I can write like this, right? E to the power of s common over the power of minus t I can write. So e to the power of s is nothing but z. So z is always equal to e to the power of s. So e to the power of s. And t is nothing but n. So we are going to get minus n. So always z is equal to the power of s. So these formulas always you have to keep in your mind. So therefore we can say this is the correct solution of this question. So now we are going to solve another question. See the question here. The question says that when a unit ramp is applied as an input to a linear time invariant system having the transfer function h of s is equal to s by s square plus 4s plus 3. The steady state output is when a unit ramp is applied as input to a linear time invariant system having the transfer function h of s is equal to s by s square plus 4s plus 3. The steady state output is. So basically what they are given is very simple. They are taking a linear time invariant system which is having the transfer function as the h of s is equal to s by s square plus 4s plus 3. Suppose if the input is a unit ramp input, then what is the steady state output that we need to figure out? So the four options, option B 1 by 3 is the correct solution of this question. So let's solve this numerical. So as you can see clearly, this is a LTI system, linear time invariant system. The transfer function of this LTI system is h of s, they are given s by s square plus 4s plus 3. The input is x of t, so output is y of t. So x of t they are given, which is the unit ramp input is r of t. So r of t is nothing but t into u of t. So x of t is equal to t into u of t. So what is x of s? You know, as I've already told you one formula, which is the Laplace transform of t to the power of n into u of t. Already I have written here. For t to the power of n into u of t, the Laplace transform is n factorial by is the power of n plus 1. So if factor n is equal to 1, we are going to get 1 factorial by is the power of 1 plus 1, which is 1 by s square. So x of s is equal to 1 by s square. So you know y of t is nothing but x of t convolution of h of t, where h of t is the impulse response. And whenever you apply the Laplace transform, then the conversion is going to become the product in the Laplace domain. So therefore, y of s is equal to x of s into h of s. X of s, you know, which is 1 by s square, and h of s, you know, which is s by s square plus 4s plus 3. So here ss cancels, we are going to get finally 1 by s into s square plus 4s plus 3. So this is the output Laplace transform that we are going to get. Y of s is equal to 1 by s into s square plus 4s plus 3. Then now in the question basically we have to find what is the final value of the output that we need to figure out. So we are going to apply the final value theorem, which is y of infinity is equal to limit s tends to 0 s into y of n. See, this is a limit t tends to infinity, y of t is equal to limit s tends to 0 s into y of s. If t is infinity means s is 0. Suppose t is 0 means s is infinity. I have already told you, right? So this is the final value theorem, which is y of infinity is equal to limit t tends to infinity, y of t is equal to limit s tends to 0 s into y of s. If t is infinity means s is 0. Suppose t is 0 means s is infinity, vice versa. So the reciprocal we can say. So what is y of infinity? Limit s tends to 0 s into what is y of s? Just now we have figured out. Start with this equation. So 1 by s into s square plus 4s plus 3. So s cancels. Then we are going to get limit s tends to 0 1 by s square plus 4s plus 3. So wherever s is there, replace s by 0. Then we are going to get finally, which is 1 by 3. So therefore, the final value of the output is nothing but which is equal to 1 by 3. Or we can say the steady state value of the output is nothing but which is equal to 1 by 3 is the correct solution of this question. So basically we have used only the final value theorem and the basic formula. So with the help of this we solved this question and we got the value which is equal to 1 by 3. So this is the correct solution of this question. So now we are going to solve another question. See the question here. The two-sided Laplace transform of x of t is equal to e to the power of minus 3t u of t plus e to the power of t 2t into u of minus t is. So basically they are given some signal. It's a two-sided signal because for t greater than 0 it is present and also t less than 0 also it is present. So we can say this is a two-sided signal. So we have to find two-sided Laplace transform means we can say what's the meaning of two-sided Laplace transform or bilateral, or we can say bilateral Laplace transform also we can say. Two-sided means the integration of time is going from minus infinity to plus infinity. One-sided means the integration is going only from t is equal to 0 to t is equal to infinity. So always remember, bilateral Laplace transform is also called a two-sided Laplace transform because the integration is going from t is equal to minus infinity to plus infinity. And unilateral Laplace transform is also called as the one-sided Laplace transform, means the integration is going from t is equal to 0 to t is equal to infinity. So in this case, as they are saying that two-sided Laplace transform is we are doing the integration from t is equal to minus infinity to t is equal to plus infinity. So what is the Laplace transform for the signal we need to figure out. So the four options, option A, which is x of s is equal to minus 5 by s square plus s minus 6, and the value of sigma is 9 from minus 3 to plus 2 is the correct solution of this question. So let's solve this numerical. So as you can see clearly, before we solve this question, let me tell you some important formulas, which is for f of t, if the Laplace transform is f of s, with an arrow which is the real part of s, then e to the power of minus 18 to f of t as the Laplace transform f of s plus a. So the ROC is nothing but e plus s by s plus a. Then we are going to get the real part of s plus a. If e to the power of 18 to f of t is the Laplace transform f of s minus a, so wherever s is there, e plus s by s minus a. So therefore, the ROC will become real part of s minus a. That's it. So this is a very basic formula, right? So f of t has the Laplace transform f of s. So therefore, we can ROC the real part of s. And e to the power of minus 18 to f of t has the Laplace transform f of s plus a. Yes, wherever s is there, e plus s by s plus a. So therefore, the ROC will become the real part of s plus a. Similarly, e to the power of 18 to f of t has the Laplace transform f of s minus a. Means wherever s is there, e plus s by s minus a. So ROC will become the real part of s minus a. So now with this concept, now we are going to solve this question. So listen carefully. For u of t, what is our Laplace transform? I have already told you. For u of t, the Laplace transform is 1 by s. With an ROC sigma greater than 0. Because u of t is the right side signal. So ROC is always to be right side, which is sigma greater than 0 here. Similarly, e to the power of minus 3t into u of t. So we are going to apply this formula, right? So here is nothing but 3. So v plus s by s plus 3. So v plus s by s plus 3. So we are going to get 1 by s plus 3. Here is nothing but the real part of, I have already told you, v plus s by s plus 3 means what you are going to get? The real part of s plus 3 greater than 0. So what you are going to get, which is nothing but, s is nothing but sigma plus j omega. And the real part I need to consider is sigma plus 3 greater than 0. So therefore sigma is greater than minus 3. This is the ROC for this one. Similarly now, u of minus t. So for u of minus t, what is the Laplace transform? 3 plus s by minus s, that's it. So therefore we are going to get minus 1 by s we are going to get. So u of minus t means 3 plus s by minus s, then we are going to get, it is minus 1 by s. As u of minus t is the left side signal, so ROC is for the left side, just sigma less than 0. So therefore we can say that for u of minus t, the Laplace transform is minus 1 by s with an ROC sigma less than 0, because whenever you are going to replace t by minus t, then replace s by minus s. So ROC is also going to get changed, which is sigma less than 0. If sigma greater than 0 means for sigma less than 0 means a mirror image, or we can say that mirror image, opposite nature. One is sigma greater than 0 means one will be sigma less than 0. So these are the, we can say mirror, or we can say basically reverse we can say. If suppose here is sigma greater than a means here it will become sigma less than a, that's it. So reverse we can say. So here sigma less than 0. Then e to the power of 2t into rho of minus t. So here we are going to use this formula. So replace s by s minus a. So replace s by s minus a. There is nothing but 2. So minus 1 by s minus 2 with an ROC. So wherever s is there, replace s by s, replace s by s minus a. So what you are going to get here, which is nothing but the real part of s minus 2 is less than 0. So s is nothing but sigma plus j omega. Only the real part I need to consider. Sigma minus 2 less than 0 means sigma less than 2. So we got the ROC, which is sigma less than 2. So finally what I am trying to tell you is very simple. For e to the power of minus 3t into u of t as a Laplace transform 1 by s plus 3 with an ROC sigma greater than minus 3. And for e to the power of 2t into u of minus t as the Laplace transform, which is minus 1 by s minus 2 with an ROC sigma less than 2. So now I want to add these two terms. Then what I need to get here, e to the power of minus 3 into u of t plus e to the power of 2t into u of minus 3 means I need to add the corresponding Laplace transforms also, which is 1 by s plus 3 plus minus 1 by s minus 2. Then what is the net ROC? The net ROC is nothing but the common ROC of these two things. One is sigma greater than minus 3 and one is sigma less than 2. So what is the common ROC? So if I draw the ROC, what you are going to get? One is sigma greater than minus 3. So sigma greater than minus 3. So what you are going to get? So let me take here. So let me take the real axis. So let me take the S plane. And here this is S plane, right? So sigma minus 3. So sigma minus 3 means here minus 3. And one is sigma 2. So less means this is the ROC. And then greater means this is the ROC, right? So this is the ROC. So this is the ROC, right? So this is the ROC. So what is the common? The common thing is this one. So this is the common ROC. So the common ROC is nothing but this is the common ROC, which is minus 3 less than sigma less than 2 is the common ROC. So only on this common ROC both are going to get defined. Then only we are going to get this sum. If both are defined, then only we are going to get this sum. Therefore, what is the net ROC? The common ROC is given to the intersection of the common ROC of both these things, which is minus 3 less than sigma less than 2. So now, 1 by s plus 3 minus 1 by s minus 2. So do the LCM, then we are going to get s minus 2 minus of s plus 3 by s plus 3 into s minus 2. So if you simplify, s and minus s cancels. So minus 2 minus 3 is minus 5. So minus 5 by s plus 3 into s minus 2. Minus 5 by s plus 3 into s minus 2 with an ROC minus 3 less than sigma less than 2. So if we do the simplification of the down part, then what you are going to get? S square minus 2s plus 3s and minus 6. And remaining thing is same. So if you simplify, minus 2s plus 3s is nothing but pluses. So finally you are going to get minus 5 by s squared plus s minus 6. Then ROC minus 3 less than sigma less than 2. So this is the Laplace transform of the signal that they have given. So this is the correct solution of this question. So always remember, for u of t the Laplace transform is 1 by s with an ROC sigma greater than 0. For u of minus t the Laplace transform is minus 1 by s with an ROC sigma less than 0. So if you remember these two basic things, getting the remaining things is a very piece of cake. That is a thing that you always have to keep in your mind. So this is the correct solution of this question. So now we are going to solve another question. See the question here. The question says that for the signal x of n shown in the figure, for the signal x of n shown in the figure, x of n is equal to 0 for n less than minus 3 and n greater than 7. So for the signal x of n, they are shown in the figure, they are given that x of n is equal to 0 for n less than minus 3 and n greater than 0 and n greater than 7 also. So x of n is equal to 0 for n less than minus 3 and also for n greater than 7. So if you see, for n greater than 7 means all these values are 0. N less than minus 3 means minus 4 is less than minus 3, minus 5 is less than minus 3. So all these values have become 0. So the signal is present only from minus 3 to 7. But the values at minus 3 its value is minus 1, at minus 2 its value is 0, at minus 1 its value is plus 1, and at 0 its value is 2, and at 1 its value is 1, and at 2 its value is 0, and at 3 its value is 1, and at 4 its value is 2, and at 5 its value is 1, and at 6 its value is 0, and at 7 its value is minus 1, and in the remaining region its value is equal to 0. So now, if x of omega is the Fourier transform of x of n, or we can say x of omega is something like discrete time Fourier transform, because the signal is a discrete time signal. So corresponding Fourier transform is also called discrete time Fourier transform. So sometimes they can write, sometimes they in the books they will write x of omega, or sometimes they also write x of e of j omega. Any of the concept is same. Some books they prefer to write x of omega, and some books they prefer to write x of e to the power of j omega. Anything is same. So it is a discrete time Fourier transform of the signal x of n. Then which one of the following is true? So these four options, which one is the true that we need to figure out? So option A is x of 0 is equal to 5, and option B, integration from minus 5 to plus 5, x of omega into d omega is equal to 2 pi, and option C, the phase angle of the x of omega is equal to minus 2 pi, and the option D, which is x of omega is equal to x of minus omega. So out of this, which is the true statement that we need to figure out? So the four options, option C is the correct solution of this question. So let's solve this numerical. So as you can see clearly, the same thing I have drawn, same signal I have drawn. I have not changed anything. I have kept as it is. So what is the signal? As you can see clearly, for n less than minus 3, its value is equal to 0, and at n greater than 7, its value is equal to 0. At n is equal to minus 3, its value is minus 1, and at n is equal to minus 2, its value is equal to 0, and at n is equal to minus 7, its value is 1, and at n is equal to 0, its value is 2. So let me write this one. I think it is not able to visible. So let me write this is 2. So this is 2. This is 1. Okay. Remaining things I think it is visible, right? So remaining things are visible. So now at n is equal to 1. So at n is equal to 1, its value is equal to 1. and at n is equal to 2, its value is equal to 0, and at n is equal to 3, its value is equal to 1, and at n is equal to 4, its value is equal to 2. Similarly, at n is equal to 5, its value is equal to 1, and at n is equal to 6, its value is equal to 0, and at n is equal to 7, its value is equal to minus 1. So these values that you can see clearly here. I think the picture was not able to visible clearly, so I have drawn it very neatly so that we can easily able to understand. Okay, same thing I have drawn it again. So this is the picture that we are going to get here. So now let us solve this one. So now, as you can see clearly, x of n is equal to 0 for n less than minus 3 as well as n greater than 7. Already they have given in the question. So what is the z transform of the x of n? Z transform nothing but x of z is equal to sigma n is equal to minus n to percentage x of n into z to the power of minus n. I have already told you that discrete Fourier transform is nothing but wherever z is there, we may z by e to the power of j omega. That's it. So x of e to the power of j omega is nothing but x of z, wherever z is there, represent by e to the power of j omega. Then what you are going to get sigma n is equal to minus n to percentage x of n into e to the power of minus j omega n or n omega. So therefore, for x of n, what is a discrete Fourier transform, which is x of e to the power of j omega, and suppose they will write which is x of omega. Anyhow, it is same. So for x of n, z transform is x of z, and for x of n, the discrete Fourier transform is x of omega or x of e to the power of j omega. Both the notations are correct. So now, what I am going to do? I can write either x of omega or either I can write x of e to the power of j omega. Everything it is same, which is equal to sigma n is equal to minus n to plus n to x of n into e to the power of minus j n omega. Already we have proved this one. So same thing I can again. I am removing this notation. I don't want to use because in the exam, in the question they have used only this notation. So I will try to use only this notation, which is x of omega is equal to sigma n is equal to minus n to plus n to x of n into e to the power of minus j n omega. So now we will see first case. For the first case that we are going to solve, what is the first option here? The option is what they are given, which is x of 0 is equal to 5. They are given means in place of omega they have kept is 0. So now we will see whether it is true or not. We will solve. So in the place of omega I am going to substitute 0, and I will see what I am going to get. So x of 0 is equal to sigma n is equal to minus n to plus n to x of n into e to the power of wherever omega is there, I replace omega by 0, and what you are going to get e to the power of minus j n into 0. So e to the power of 0 is nothing but 1. So therefore we are going to get sigma n is equal to minus n to plus n to x of n. Right? So now x of 0 is equal to, so now what I will do? I have to do just the summation of all the values. As I have already told you, the x of n is having only values from minus 3 to plus 7, and the remaining values of 0 means I need to do the addition of all these values of x of n, which is then what you are going to get minus 1 plus 0 plus 1 plus 2 plus 1 plus 0 plus 1 plus 2 plus 1 plus 0 minus 1. That's it. These are all the values of the x of n. So these are the values of all of the x of n, which is minus 1 plus 0 plus 1 plus 2 plus 1 plus 0 plus 1 plus 2 plus 1 plus 0 minus 1. So if we add all these values, you are going to get its value is equal to 6. So x of 0 is nothing but 6. But in the option they have what they have given, x of 0 is equal to 5. So definitely we can say this is wrong. But what is the actual one? The actual one is the x of 0 is nothing but 6. This is a true statement, but in the option they are given, option A is the wrong. Now let's go for the option B. So option B now we are going to solve. What is the option B? They have given integration of minus pi to plus pi x of omega into d omega. They are given just 2 pi. Now we will see whether this is true or not that we are going to solve. So now if you see x of omega already I given it is sigma n is equal to minus n to plus n to x of n into e to the power of minus j n omega. Suppose if you want to write in the reverse fashion, here if you know x of 1, how to get the x of omega I have given. But how to write the reverse fashion, which is x of 1 is equal to 1 by 2 pi integration of omega is equal to minus pi to plus pi x of omega into e to the power of plus j n omega into d omega. This one already I have told you, right? So this is the x of n. X of n is equal to 1 by 2 pi integration of omega is equal to minus pi to plus pi x of omega into e to the power of j n omega into d omega. This formula already I have told you in my classes. So if you know x of omega, how to get x of n, this is the formula. Discrete inverse discrete Fourier transform. This is the discrete Fourier transform, and this is the inverse discrete Fourier transform. So x of n is equal to 1 by 2 pi integration of omega is equal to minus pi to plus pi x of omega into e to the power of j n omega, where minus is plus d omega. So this one you have to keep in mind. So in the case of the time domain, it will become omega is equal to minus into plus infinity. But in the case of discrete time, it will become only from omega is equal to minus pi to plus pi, only it will become only for one time term, which is 2 pi. So now in place of n, I will substitute 0 and I will see what I am going to get. In place of n, I am going to substitute 0, then what I am going to get? S of 0 is equal to 1 by 2 pi integration of omega is equal to minus pi to plus 5. So n is equal to 0 means e to the power of 0 is nothing but 1. We are going to get x of omega into d omega. Then what is this value? This value is equal to 2 pi into x of 0. So integration of omega is equal to minus pi to plus 5. X of omega into d omega is equal to 2 pi into x of 0. So x of 0 value we know. What is the value of x of 0? X of 0 is nothing but 2. So therefore multiply by 2. So 4 pi into 2 is nothing but 4 pi. So 4 pi is the correct solution of this question. But what they have given? They have given 2 pi. So definitely this is wrong. So definitely it is wrong. So what is the correct solution here? Integration of minus pi to plus pi. X of omega into d omega is nothing but 4 pi. This is the actual one, but they have given the wrong one. Now let's go for the option C. So option C, what they have given? The phase angle of x of omega they have given is equal to minus 2 omega they have given. Now let us see whether it is true or not. We will see. Now, so option C, now we are going to analyze. Suppose y of n is nothing but I am going to assume another signal y of n is equal to x of n plus 2. So n plus 2 is nothing but what is the meaning of this one? N plus 2. So n plus 2 means I need to advance the signal by 2 limits. I need to advance the signal by 2 units. I need to advance the signal by 2 units. So how I am going to get? Let me draw the picture. So let me draw the picture by advancing the signal by 2 units. So let me draw the picture. So this is a y of n. So y of n I can write x of n minus of minus 2 I can write. It is equal to x of n plus 2. So for x of n, what is the starting value? From minus 3 to it has become up to plus 7. So now for if you want y of n means we have to add minus 2 for initial position at final position. So minus 2 minus 3 is nothing but minus 5. Minus 2 plus 7 is nothing but what we are going to get? Minus 2 plus 7 is nothing but 5 you are going to get, right? Then what is the thing here? This will be minus 1, minus 2, minus 3, minus 4, and here it is a minus 5. So it is 0, here 1, here 2, here 3, and here 4, and here 5. So let me draw the picture with the other input and let us see what is going to get happen. So now this signal is starting from minus 5 to plus 5, right? So what is the value? The first value is minus 1. So this is a minus 1. Then comes the 0. Then comes the 0. Then comes the plus 1. Then comes the plus 1. Then comes the plus 2. So then comes the plus 2. Then comes the plus 1. Then comes the plus 1. Then comes the 0. Okay. Then comes the plus 1. Okay. Then comes the plus 2. Okay. Then comes the plus 2. So again, then comes the plus 1. So then comes the plus 1. And then comes the, you can say, this is a 0. This comes the 0. Then comes the minus 1. So if you see clearly, it is a symmetric signal. It is a symmetric signal or even signal. So you can see here 1, here 1, here 2, here 2, here 1, here 1, here 0, here 0, here minus 1, here minus 1. So we can say this is a symmetric signal. So y of n is equal to x of n plus 2 is a symmetric or even signal with respect to the axis. So therefore same thing I have written. So y of n is equal to x of n plus 2 is a symmetric with respect to the axis, or we can say it is a even signal. Suppose for x of n, the discrete time Fourier transform is x of omega. Then y of n I am going to take. Y of n is nothing but x of n plus 2. So what is the discrete time Fourier transform? And x of n plus 2 is nothing but it is an even signal, right? So discrete time Fourier transform. So discrete time Fourier transform means how you are going to get and what I told you, which is x of omega into e to the power of 2 omega j. E to the power of 2 omega j. As I already told you, as I already told you, one important formula. See, I already told you. Suppose for x of t, the Laplace transform is x of s. Then for x of t minus a, what is the Laplace transform? E to the power of minus as into x of s. So similarly, here is nothing but minus 2. So here is nothing but minus 2. Then we are going to get e to the power of 2s into x of s. So s is nothing but omega. So j omega right here. Then what we are going to get here? E to the power of 2 omega j x of omega. So this is what I have written. Same thing, right? Same thing, right? So the discrete time Fourier transform is s of omega into e to the power of 2 omega j. So this is nothing but for y of n, what is discrete Fourier transform, which is y of omega. So let me write this part so that it can be clearly visible for you. So like this always you have to keep in your mind. So like this always you have to understand each and everything in order to solve the questions in the examination. Okay. So I have wrapped this part. So now everything like this it is clear. So let me, okay. So now we will see it. So as you can see clearly, this y of, see as this y of n is the even signal. Then what is y of omega? As y of n is the even signal, and I've already told you the discrete and Fourier transform will be real and even nature. I already told you whether it is a continuous time case or whether it is discrete time case, the phenomenon is same. When the given signal is a real signal and even nature, then its Fourier transform is also even signal, a real part with the even nature. This one I already told you, right? So whenever a given signal is a real and a even nature, then its corresponding Fourier transform will also, it will have only a real part with even nature. So the x of omega will have only a real part and it is even in nature. I have already told you that in the case of continuous time case, if a given signal is a real signal with an even nature, then its corresponding Fourier transform will have only a real part and it is even in nature. So now y of omega will have only a real part and it is even in nature. Then as you can see clearly, what I am going to do, this should be only a real part. It should be only a real part. It should have only a real part. Real part only it should have. So I am going to assume this y of omega is nothing but a. I am going to assume. So I am going to assume its value is equal to a because it must have only a real value. Real value means some constant only, some value which it should present. Then I am going to assume its value is equal to a. Then what is x of omega? Then x of omega is nothing but a into the power of minus 2 omega j. So you can do it vice versa also. Let x of omega is equal to a into the power of minus 2 omega j. Then what is y of omega? X of omega into the power of 2 omega j. So if you multiply these two things, then what you are going to get? A into the power of minus 2 omega j into the power of 2 j omega. So these both are going to get cancelled and we are going to get finally a. So therefore, only real part is going to be present and is even in nature. As I already told you. So what is x of omega? X of omega is nothing but a into the power of minus 2 omega j. So a into the power of minus 2 omega j. So therefore this is what that we are going to get. So what is x of omega now? A into the power of minus 2 omega j. Then what is the magnitude of the x of omega? The magnitude of the x of omega is equal to a. It's a some constant. It is some constant. And what is the phase angle of x of omega? Which is minus 2 omega. As you can see clearly from the picture. So what is the magnitude of the x of omega? Which is equal to a. And the phase angle of x of omega is nothing but minus 2 omega. So therefore this is the phase angle of the x of omega, which is minus 2 omega. This is what we have proved, right? Same thing we have done. The phase angle of x of omega is nothing but minus 2 omega. Same thing we have proved, right? So this is the correct one. Out of A, B, C, this is a true. Let's finally go for the option B also. We will see whether this is a true or not. This also we are going to prove. See now, what is x of omega? X of omega is equal to sigma is equal to minus 7 to plus 17. X of omega with the power of minus j in omega. Already we know. What is x of minus omega? Whenever omega is there, we will omega minus omega. Then what you are going to get? Sigma is equal to minus 7 to plus 17. X of omega with the power of j in omega. Then what is this one? This is the complex conjugate of this one. So this is nothing but complex conjugate of this one. So x of omega is not equal to x of minus omega, but x of omega is equal to x of minus omega whole conjugate or vice versa. Do the conjugate of both sides, and what we are going to get? S conjugate of omega is equal to x of minus omega, because conjugate are going to get cancelled. Then we are going to get like this. Both are not equal. Actually, they are going to equal by conjugate. So x of omega is equal to x of minus omega conjugate, or s conjugate of omega is equal to x of minus omega. As you can see clearly from this picture, but they are being equal. So this is the wrong way. So this is the wrong. But what is the actual one? What is the actual one? Which is x of omega is equal to x of minus omega with a whole conjugate. So finally, what are the true statements? We can say the x of 0 is equal to 6 and integration of minus pi to pi, x of omega and d omega is equal to 4 pi, and the phase angle of x of omega is equal to minus 2 omega, and x of omega is equal to x of minus omega whole conjugate. So these are the true statements. But in the options out of option A and option B and option C and option D, only option C is the correct solution of this question. So now we are going to solve another question. See the question here. The question says that two systems T1 and T2 are cascaded to get the system T as shown in the figure. So listen carefully. Two systems T1 and T2 are cascaded to get the system T as shown in the figure. So as you can see clearly, there are two systems, T1 and T2. They are cascaded in order to get the overall system T. Therefore, the input is at x of n and the output is y of n. Which of the following statement is true? So, which of the following statement is true that we need to figure out? So, out of these four statements, it is the true statement that we need to figure out. Option A, if both T1 and T2 are linear, then T is not necessarily linear. Option B, if T1 and T2 are time invariant, then T is not necessarily time invariant. Option C, if both T1 and T2 are non-linear, then T is not necessarily non-linear. Option D, if both T1 and T2 are causal, then T is not necessarily causal. So out of this, which is the true statement that we need to figure out. So option C is the correct solution of this question, which is if both T1 and T2 are non-linear, then T is not necessarily non-linear in nature. So this is the correct solution of this question. So let's solve this numerical. So basically, what they are given two systems, right? They are given two systems, T1 and T2. So first system is here. I am going to assume, see basically in the question what they are given, there are two systems they are given. So there are two systems, let me draw the picture here. So this is a system 1 and this is a system 2. So T1 and T2. So they are cascaded. So the input is x of n and the output is y of n. So okay, input is x of n and output is y of n. As you can see clearly, x of n and y of n. So now what I am going to do, for a system 1, the impulse response is x1 of n, and for the system 2, the impulse response is x2 of n. x1 of n and x2 of n. So whenever you are going to cascade for the overall system, what is the impulse response h1 of n, combination of the x2 of n, and the input is the x of n and the output is the y of n, right? Y of n. Input is x of n and output is the y of n for the overall system. So now if you see clearly one important point that we are going to get here. So whenever you are going to cascade the two systems, the overall system impulse response is the combination of the individual system impulse response for the systems, but they are the LTI systems. Now if you see some important point I am going to tell you. Suppose I am going to assume the system 1 has a non-linear system and the system 2 is also non-linear system. So it's an example I am going to take here. It is a exponential and here it is a logarithm with a base e. Then what is going to happen? Let us see here. So why this system is a non-linear? So this is the first system. What is the first system? Is a non-linear system. It is exponential. Yes, then the input is x of t. Then what is the output that you are going to get? Which is e to the power of x of t. But definitely this is a non-linear system because if we give x1 as the input, then we are going to get x1 of t as the output. Similarly, if we give x2 as the input, then what is the output? Which is y2 is equal to e to the power of x2 of t. If we give the input x3 as the input, then what is the output? y3 is equal to e to the power of x3 of t. If this new input is a summation of the two previous inputs, then what is the output that we have got? E to the power of x1 plus x2, which is nothing but it is e to the power of x1 into e to the power of x2. It is not equal to y1 plus y2. As the input is summation of the two previous inputs, but the output is not equal to summation of two previous outputs. So definitely we can say the given system is said to be non-linear system. Similarly, the second system is the logarithm system. Let me prove this one also. So this is the second system. This is also logarithm system. It's also non-linear system. Let me prove this one. Suppose if the input is x of t, then what is the output? The output is y of t is equal to log with a base e x of t. Right? Suppose if the input is x1 of t, then what is the output that we are going to get? y1 is equal to log x1 with a base e. Suppose if the input is the x2, then what is the output you are going to get? y2 is equal to log x2 with a base e. Similarly, if the input is the x3, then what is the output that we are going to get? y3 is equal to log x3 with a base e. Suppose if this new input is a summation of the two previous inputs, then what is the output that I am going to get? Log of x1 plus x2 with a base e. So log of n plus n. And what I do log m into n is nothing but log n plus log n, and log n by n is nothing but log n minus log n. But this is not equal to summation of the two previous outputs. So summation of two previous outputs. So as the input summation of the two previous input, but the output is not equal to summation of two previous outputs. So definitely we can say this given system is also a non-linear system. So whenever the system 1 is a non-linear system and the system 2 is also non-linear system, and I have taken like this and I will do the cascade, then what is the thing that going to happen? Now we will see. I have proved that both systems are non-linear system. Suppose for the first system, if the input is x of t, what is the output you are going to get? E to the power of x of t. Similarly, if the For the second system, what is the output that we are going to get, which is log with a base in the input. The input is now e to the power of x of t. So if you simplify, what we are going to get, x of t is going to come outside. So y of t is nothing but x of t. So what is the overall system? The overall system is nothing but is the identical system, because whatever the input, same thing that we are going to get in the output also. So we can say this is a identical system. So identical system is whatever the input, same thing that we are going to get in the output also. Then whether the system is linear or not, yes, it is a linear, because when the input is x1, the output is also x1. If the input is x2, the output is also x2. If the input is x3, then the output is also x3. If this new input is summation of the two previous inputs, then the output is also equal to summation of two previous outputs. So therefore we can say that the given system is said to be a linear system. So this is nothing but a linear system. Even though you are going to cascade the two nonlinear system, but the resultant system is a linear system that you have got. So therefore we can say that even though you are going to cascade two nonlinear systems, but the resultant is a linear system. That is what I am trying to tell you. Means whenever you are going to cascade two nonlinear systems, the resultant can be either linear or either it can be non-linear also. Listen carefully. Whenever you are going to cascade two non-linear systems, the resultant can be either linear or non-linear also. Okay? So therefore, what here we are saying that T1 is a non-linear system, T2 is a non-linear system, but T, in this case, we have got it is a linear system. So cascading of two non-linear systems results in linear or non-linear as a resultant system. I already told you, whenever you are going to cascade two non-linear systems, the resultant system can be either linear system or either it can be non-linear also. If both T1 and T2 are non-linear systems, then T is not necessarily non-linear. Means what is the meaning of this one? If both T1 and T2 are non-linear systems, then the resultant is T is not necessarily non-linear. Means it can be either linear or either it can be non-linear. That is the meaning of this one. So therefore, what I can say, cascading of two non-linear systems is going to result in a system which is either linear in system or it is a non-linear as a system. So therefore, we can say whenever we are going to cascade two non-linear systems, the resultant system can be either linear system or either it can be non-linear system also. This point always you have to keep in your mind. So therefore, let me write here this point here. So whenever we are going to cascade two non-linear systems, the resultant can be either linear system or non-linear system also. Similarly, if you are going to cascade two causal systems, the resultant is always a causal system only. This point always you have to keep in your mind. So whenever you are going to cascade two nonlinear systems, the resultant can be either linear system or nonlinear system. Similarly, whenever you are going to cascade two causal systems, the resultant is always a causal system. This one I have already told you so many number of times. So therefore, we can say cascading of two causal systems resulted in always a causal system only, because I have already told you for the resultant system, the impulse response is a combination of the initial system impulse response. If H1 of t is a causal signal and H2 of t is also causal signal, then the resultant signal is always a causal signal. So therefore, we can say cascading of two causal systems is always going to give you a causal system only. It means the combination of two causal signals is always going to give you causal signal. What is the meaning of causal signal? Means that for that signal, for t less than 0, its value is equal to 0. So therefore, causal signal is also called as a right-sided signal also, we can say. So finally, I can say, whenever you are going to cascade two nonlinear systems, the resultant can be either linear system or either it can be nonlinear system. Similarly, by cascading of two causal systems, the resultant is always a causal system. This point always you have to keep in your mind. So therefore, we can say here, what is the option? So they are saying if both T1 and T2 are nonlinear, then T is not necessarily nonlinear. Not necessarily nonlinear means what is the meaning of this one? Not necessarily nonlinear means it can be nonlinear or it can be linear. That is the meaning of this one. Necessarily means if suppose there is not is not there means T is necessary non-linear means only they are saying it is a non-linear. But not necessarily means not compulsory. Not compulsory means it can be the non-linear or linear also. So option C is the correct solution of this question. But in option D, if you see, if both T1 and T2 are causal, then T is not necessarily causal means it is wrong. It should be compulsory causal. So if this is not there means this is also true. So I wanted to bring up one important statement which is that whenever you are going to cascade two nonlinear systems, the resultant system can be either nonlinear system or linear system. And similarly, the cascading of two causal systems is always going to give you a causal system. This point always you have to keep in your mind here. So this is the correct solution on this question. Suppose this is not there, means this is also true, but here they are kept not. So option D is also wrong. So option C is the correct solution on this question. Now we are going to solve the another question. See the question here. If x of n is equal to 2 by pi for n is equal to 0 and its value is equal to sine 2n by pi n for n not equal to 0, then what is the energy of the signal x of n? So basically, if you see clearly, there is a discrete time signal. So for discrete time signal, for n is equal to 0, its value is equal to 2 by pi, and for n not equal to 0, its value is equal to sine 2n by pi n. Then we have to find what is the energy of the signal x of n. We need to figure out. So the four options, option A 2 by pi is the correct solution of this question. So let's solve this numerical. So as you can see clearly, before we solve this question, first let me tell you some concepts. Then we can solve the question. Suppose x of t is a continuous time signal. Suppose I will take some x of t is a continuous time signal, which is a rectangular pulse. So for rectangular pulse means its amplitude is equal to a, and it's to be this t. T means equal parts, we are going to divide t by 2 minus t by 2. So what is the Fourier transform of this one, which is x of t means x of omega, which is equal to area into saw of omega into width by 2. Area into saw into omega into width by 2, as I already told you for rectangular pulse. Suppose if it is a triangular pulse means what is the Fourier transform? Area into saw square of omega into width by 4. I already told you, right? So for this rectangular pulse, what is the Fourier transform? X of omega is called area into saw of omega into width by 2. What is the area? A into t. A into t. What is width? It is t. So therefore we can say AT into saw of omega into t by 2. So now I have already told you what is saw of x. Saw of x is nothing but sin x by x. And what is sinc of x, which is sin pi x by pi x. I have already told you saw of x is nothing but sin x by x, and sinc of x is nothing but sin pi x by pi x. So by comparing this, what we can say, sinc x is nothing but saw of pi x. Sinc x is nothing but saw of pi x means if you replace x by pi x in the saw, then we are going to get same thing. So therefore sinc of x is equal to saw of pi x. So now saw means sampling function. Saw means sampling function. Then what is x of omega? X of omega is equal to AT into saw of omega into t by 2. I have already told you saw of x is nothing but sin x by x. X is equal to omega into t by 2. So sin of omega into t by 2 by omega into t by 2. So if you simplify it, t cancels, then finally we are going to get 2a by omega into sin of omega into t by 2. Right? So this is the value that we are going to get. So for f of t, I have already told you for f of t, if the Fourier transform is f of omega, then capital F of t has a Fourier transform 2 pi into f of minus omega. This is called duality principle. This is called as the duality theorem. So this is called as the duality theorem or duality principle, we can say. So therefore what we can say, f of t has a Fourier transform capital F of omega, then capital F of t has a Fourier transform 2 pi into small f of minus omega. So this is the formula that you always have to keep in mind. This is called a duality theorem. So f of t has a Fourier transform capital F of omega, then capital F of t has a Fourier transform 2 pi into small f of minus omega. So this is called as the duality theorem or duality principle. Then here basically what I want to do, I want to basically convert this into this is basically in the frequency domain, right? I want to convert this into time domain, and I want to get what is the corresponding Fourier transform I want to get. So wherever omega is there, replace omega by t, that's it. So therefore what is the capital F of t is 2a by t into sin of t into t by 2. So 2a by t into sin of t into capital t by 2 as a Fourier transform 2 pi into f of minus omega. But f of minus omega is nothing but this. This I have assumed f of t, and this is I have assumed f of omega. So 2 pi into f of minus omega as x of t is as f of t, or I can x of t or f of t as it's an even signal. So as you can see clearly that as it's an even signal. Let me assume this is f of t. So f of t is equal to f of minus t as I have replaced t by omega. Sorry, t by minus omega I have replaced, right? So f of minus omega is equal to f of omega as it's an even signal. So f of minus omega is equal to f of omega in this case. So what you are going to get same thing, but you have to multiply by 2 pi. So 2 pi means this amplitude is going to multiply by 2 pi. So you are going to get 2 pi a into for a width of same width, just t by 2 and minus t by 2. But now it is in the frequency domain, which is omega. So therefore for f of t is equal to 2a by t I have taken inside. So 2a into sin of t by 2 by t as a Fourier transform in this fashion. Same thing, I have drawn it. So by using this duality principle, I have got this one, right? So this is the, for this one, time domain expression, this is the, we are going to get corresponding the Fourier transform that we are going to get. So now I will do some simplifications, listen carefully. Suppose if I multiply by pi on the both sides, then what I am going to get? Here by pi, here also by pi. So you are going to get 2 only. So 2 into, what is the amplitude here? So 2a you are going to get. So 2a, here minus t by 2, t by 2, here multiply by pi. So 2a by t pi into sine of t into t by 2. Same thing, right? So now I am going to assume, I am going to assume capital T is equal to 4, I am going to assume. So I am going to assume let capital T is equal to 4 and A is equal to half. That I am going to assume. And what I am going to get, we will see. Let capital T is equal to 4 and capital A is equal to half. Then what I am going to get? So as A is equal to half, so 2 into half is nothing but 1. Sine of, if capital T is equal to 4, so 4 by 2 is nothing but 2. So 2t are going to get sine of 2t by t pi as a Fourier transform. As you know, A is equal to half. 2 into half is nothing but 1 we are going to get. And t is equal to 4, 4 by 2 is nothing but 2 here. Minus 4 by 2 is nothing but minus 2. So this is what we are going to get. For sine 2t by t pi, for sine 2t by t pi as a Fourier transform like this, rectangular pulse of 1 from minus 2 to plus 2 in the frequency domain omega. So for sine 2t by t pi as a Fourier transform like this one, is having a pulse from, it is having amplitude of 1 from minus 2 to 2 in the frequency domain. So now I am going to convert to discrete time domain by replacing t by n. So this is up to now we discussed in the continuous time case. So now I want to convert this continuous time case into the discrete time case by replacing t by n. So now I am going to convert the continuous time case to discrete time case by replacing t by n. So convert to discrete time domain by replacing t by n. So this is a continuous time case, right? Up to now we have studied only continuous time case. So now I want to replace this continuous time case by discrete time case. So therefore we have to replace t by n. So wherever t is there, small t, replace t by n. So what we are going to get, with this I am going to assume capital f of t, right? But now, from now onwards I will assume this is small f of t, because anyway we know everything, right? So we know everything, right? So now I will assume for simplicity small f of t, because we know each and everything. So no need of anything extra. So f of n is equal to sine 2n by n pi as a Fourier transform, same as it is. Minus 2 to plus 2, it is values 1. So, you know, 2 is less than pi, right? So this is plus pi and this is minus pi. So this is plus pi, minus pi, because pi is nothing but 3.14 and 2 is less than, so therefore this is going to lie within the plus pi to minus pi. Then what is f of n? So if you see clearly, suppose if you substitute n is equal to 0, then what is the value you are going to get? Suppose if in the f of n, if you substitute n is equal to 0, then what are you going to get? Sine 0 by 0. 0 by 0 is indeterminate, so you have to go for the L'Hospital rule. Sine derivative is cos 2n into 2 by n pi, derivative is pi. Now substitute n is equal to 0, then what you are going to get? Cos 0 is 1, so 2 by pi you are going to get. So n is equal to 0, its value is equal to 2 by pi, and when not equal to 0, its value is equal to sine 2n by n pi, right? So this is the f of n. So this is the f of n. This is what they have given our question, right? In the question what they have given, the signal x of n is nothing but for n is equal to 0, its value is equal to 2 by pi, and for n not equal to 0, its value is equal to sine 2n by pi n. Same thing. For n is equal to 0, its value is equal to 2 by pi, and for n not equal to 0, its value is equal to sine 2n by n pi. Same thing. So what's the corresponding Fourier transform? We are going to get like this. From minus 2 to plus 2, its value is equal to 1, and for remaining all the value, its value is equal to 0. This we can write. Here I have taken small f of n, right? So I can write what is that, as it's a discrete time signal, then what is this corresponding discrete time Fourier transform, f of omega or f of e to the power of j omega? Everything is same. I have already told you. Then what is the formula of the energy in the discrete time case? What is the formula of the energy in the discrete time case? E is equal to sigma m is equal to minus m to plus m t. Mod of f of n whole square is equal to 1 by 2 pi integration of minus pi to plus pi mod of f of e to the power of j omega whole square d omega. So this formula, as I've already told you so many number of times, so you have to remember the expression of the energy in the discrete time case, which is E is equal to sigma m is equal to minus m to plus m t. Mod of f of n whole square is equal to 1 by 2 pi integration over the period from minus pi to pi, which is mod of f of e to the power of j omega whole square into d omega. Some books they will take f of omega and some books they will take f of e to the power of j omega. Anyhow, the concept is same. So now we are instead of using the in the discrete time case, we will see in the discrete time Fourier transform case, because here doing the simplification is very simple. So E is equal to 1 by 2 pi integration of minus omega is equal to minus pi to plus pi mod of f of e to the power of j omega whole square into d omega. As you see clearly, as we are doing integration from minus pi to plus pi, then but the limits are going to have only from minus 2 to plus 2 because therefore the remaining case its value is equal to 0. So therefore you have to go from integration from omega is equal to minus 2 to plus 2. And in that case, what is the value? What is the magnitude value which is nothing but 1? So 1 square into d omega. So 1 square is nothing but 1. So integration of d omega is nothing but omega. Substitute limit minus 2 plus 2. So upper limit minus lower limit is 2 minus of minus 2. So 2 plus 2 is 4. 4 by 2 pi is nothing but 4 by 2 is nothing but 2 by pi. 2 by pi joules is the Athara solution of this question. So basically how we solve this question? First we have learned about the continuous time case. So with the help of continuous time case, we have given the expression, and with the help of the converting from continuous time case to discrete time case, we got a Fourier transform for the given signal, and with the help of the energy of the expression of the energy in the discrete time case, we have solved this question. So doing in the discrete time case, it may be very hard, and so that is the reason we have used the discrete time Fourier transform in order to solve this question. So 2 by pi joules is the correct solution of this question. So I want you to remember only the equation of the energy in the discrete time case, which is E is equal to sigma n is equal to minus m to plus m mod of f of n whole square is equal to 1 by 2 pi integration of omega is equal to minus 5 to plus 5 mod of f of e to the power of j omega whole square into d omega. These formulas always you have to keep in your mind here. So let me give you the formulas of the expression of the energy in the continuous time case as well as the discrete time case. E is equal to integration of t is equal to minus m to plus m mod of f of t whole square dt is equal to 1 by 2 pi integration of omega is equal to minus m to plus m mod of f of omega whole square d omega. But the expression of the energy in the discrete time case, which is E is equal to sigma m is equal to minus m to plus m mod of f of n whole square is equal to 1 by 2 pi integration of omega is equal to minus pi to plus pi mod of f of omega or mod of f of e to the power of j omega whole square into d omega. If you see in both the cases, here the integration is from omega is equal to minus m to plus m, but here the integration is only from omega is equal to minus pi to plus pi. Why it is like this? Because here in the continuous time case, the f of omega is aperiodic, whereas in the case of the discrete time case, this f of omega is nothing but is a periodic. That is the reason we have to do only for a one period only. So this formula always you have to keep in your mind. So the expression of the energy in the continuous time case, which is E is equal to integration of t is equal to minus m to plus mod of f of t whole square dt is equal to 1 by 2 pi integration of omega is equal to minus m to plus mod of f of omega whole square d omega. And the expression of the energy in the discrete time case, which is E is equal to sigma m is equal to minus m to plus mod of f of n whole square is equal to 1 by 2 pi integration of omega is equal to minus pi to plus pi mod of f of omega mod of f of e to the power of j omega whole square into d omega. So basically what I am trying to tell you is very simple, which is here we have to use the integration from omega is equal to minus m to plus m because in the continuous time case, f of omega is a periodic signal, whereas in the discrete time case, as mod of f of omega or mod of f of e to the power of j omega, it is a periodic signal. So we have to do only for one period, which is 0 to from minus pi to plus pi, or you can go from any period only for 2 pi only we have to do the period. So this formula always you have to keep in your mind, the expression of the energy in the continuous time case and the expression of the energy in the discrete time case. These two formulas always you have to keep in your mind. Then only you can solve this type of questions in a very fraction of second. So this is the correct solution of this question. So now we are going to solve the another question. See the question here. Consider the discrete time signal. So consider the discrete time signal x of n is equal to 1 comma 1 comma 1 comma 1 comma 0.5 comma 0.5. Then y of n is equal to convolution of the delta of n minus 1 comma x of n is. So basically in this question they are given a discrete time signal x of n. They are given the discrete time signal x of n, and they are asking what is the convolution of the x of n as well as the delta of n minus 1. They are asking this question. It's a very basic question. The correct solution of this question is nothing but x of n minus 1. So listen carefully. What they are asking is convolution of the x of n, convolution of the delta of n minus 1, or it is equal to x of n minus 1, because I have already told you what is the basic formula. X of n minus n naught, convolution of the, let me take this n1, the delta of n minus n2 is nothing but which is x of n minus of n1 plus n2. So in this case n1 is nothing but 0 and n2 is equal to 1. So if you substitute, what we are going to get x of n minus of 0 plus 1 is equal to 1. So what we are going to get x of n minus 1. So based on the basic formula, we have solved this question. So basically, it's a very easy question. No need to think more about this one. So therefore, we can say the convolution of the x of n into delta of n minus 1 is nothing but x of n minus 1 is the correct solution of this question. But let me discuss something more about this one. So option C is the correct solution of this question. So now, as you can see clearly, y of n is nothing but x of n convolution of delta of n minus 1. As the convolution is going to satisfy the convolutive property, we can add in the reverse fashion also this delta of n minus 1 convolution of x of n, which is nothing but x of n minus 1. As I already told you, when x of n convolution of h of n is equal to y of n, then x of n minus n1 convolution of h of n minus n2 is equal to y of n minus of n1 plus n2. So this is the basic formula, as I already told you so many number of times, which is x of n convolution of h of n is equal to y of n, then x of n minus n1 convolution of h of n minus n2 is equal to y of n minus of n1 plus n2. So this is the basic formula. Now you can also remember this formula, which is I have already told you f of t convolution of the delta of t is equal to f of t. Similarly, f of t minus t1 convolution of the delta of t minus t2 is nothing but it is equal to f of t minus of t1 plus t2. So these things always you have to keep in the mind. So with the help of this, we have solved this question and we got the solution. But let me tell you some more important formulas also, which are very important. So delta of a is always equal to delta of n, whether a is positive or whether a is negative. This is always true. Delta of n is always equal to delta of n, whether a is positive or a is negative. Whereas delta of a is always equal to 1 by mod a delta of t, then a can be either positive or a can be either negative. So if you see clearly, this is a huge difference between the continuous time case as well as discrete time case. In discrete time case, there is nothing like 1 by mod a, but in the case of continuous time case, there is a 1 by mod a. This point always you have to keep in mind, because delta of n is equal to 1 for n is equal to 0 and its value is equal to 0 for n not equal to 0. But delta of t, it doesn't have any value. It has an infinite amplitude, but it has a area only we can say is a 1. That is the reason delta of t is nothing but it's an unbounded signal, because its amplitude is equal to infinity, but it has only area of 1. That is the reason delta of t or the impulse signal, and delta of t means continuous time impulse signal, it is an unbounded signal. So therefore we can say delta of n is always equal to delta of n, whether a is positive or a is negative, whereas delta of 8 is always equal to 1 by mod a into delta of t, where a can be either positive or a can be negative. So this is a huge difference between the continuous time case as well as the discrete time case. And one more important formula, which is if f of t convolution of h of t is equal to y of t, then f of ad convolution of h of at is equal to 1 by mod a into y of at, where a can be either positive or a can be either negative. So this formula also you have to keep in your mind. So f of t convolution of h of t is equal to y of t, then f of at convolution of h of at is equal to 1 by mod a into y of at. So this formula always you have to keep in your mind. So a can be either positive or a can be either negative. So finally I can say if f of t convolution of h of t is equal to y of t, then f of ad convolution of h of at is equal to 1 by mod a into y of at. A can be positive or a can be negative. So these important formulas you have to keep in your mind. So finally I can say the important formulas are delta of n is equal to delta of n, where a can be positive or a can be negative, and delta of at is equal to 1 by mod a into delta of t, where a can be positive or a can be negative. And f of t, the convolution of h of t is equal to y of t, then f of ad convolution of h of at is equal to 1 by mod a into y of at, where a can be positive or a can be negative. So this is the actual solution of this question. So now we are going to solve the another question. See the question here. The question says that the average value of the waveform is, what is the average value of the waveform? So basically they are doing some signal waveform and they are asking what is the average value of the signal that we need to figure out. So it is a voltage signal, right? It is a voltage signal. It is a square wave. Basically it is a square wave for half a cycle its value is plus 14, and for the remaining half a cycle its value is equal to minus 6 volt. The signal is having a period of 2 because it's a periodic signal, and the time is in terms of milliseconds. So what we can say, this signal is a periodic signal with a period of 2 milliseconds, with a period of 2 milliseconds. So for the signal we have to find what is the average value we need to figure out. So for the 4 options, option B 4 volt is the correct solution of this question. So let's solve this numerical. Same thing, I have drawn signal f of t. So for 0 to 1 its value is equal to plus 14, and from 1 to 2 its value is equal to minus 6. Same graph is going to repeat here also. As it's a periodic signal, so time in terms of milliseconds. So we have to find what is the average value. So what is the average value? Average value is equal to 1 by t, integration over the 0 to t, x of t dt, f of t dt. So average is equal to 1 by t into integration of 0 to t, f of t dt. So I already told you the formula. What is the average value? Average value is nothing but average value is equal to integration of the 0 to t f of t into dt by t. This is the average value. And what is the RMS value? RMS value is nothing but under root over integration of 0 to t f of t whole square dt by t. So these formulas you have to keep in your mind. So the first one is the average value and second one is the RMS value. What is the average value? Integration of 0 to t f of t dt by capital T, and RMS value is equal to under root of 0 to integration over the 0 to t f of t whole square dt by t. So these formulas you have to keep in your mind. So we are going to use the average value formula, which is 1 by t integration over 0 to t f of t dt. So what is the t? T is equal to 2 milliseconds, right? So I'll take only 2 because milliseconds they are going to get cancelled. So I don't take the milliseconds, I'll take only 2. So 1 by 2 integration over the 0 to 2 f of t dt. So 1 by 2 integration over the, because f of t is having different values for different value of time. So we are doing only integration from 0 to 2. From 0 to 1 its value is equal to plus 14, and from 1 to 2 its value is equal to minus 6. So from 0 to 1 f of t dt plus 1 to 2 f of t dt. So for 0 to 1 its f of t value is equal to 14, and for 1 to 2 its value is equal to minus 6. Same thing I have substituted here, then I have got 1 by 2 integration of 0 to 1 14 dt plus 1 to 2 integration of 1 to 2 minus 6 into dt. As 14 is a constant, we can take it outside the integration, and integration of dt is nothing but t substitute the limit 0 to 1. Minus 6 is a constant, we can take it outside the integration. So minus 6 into integration of dt is nothing but t substitute the limits 1 to 2. Upper limit minus lower limit. So here 1 minus 0 is nothing but 1. So 1 into 14 is equal to plus 14 minus 6 into here upper limit minus lower limit. So 2 minus 1 is nothing but 1. So 1 into 6 is equal to 6. So here minus is there. So minus 6 we are going to get. So 14 minus 6 by 2. 14 minus 6 is 8. 8 by 2 is nothing but 4. So 4 volts that we are going to get. Because I have not taken here milliseconds. See, whether it is in milliseconds or seconds, any of they are going to get cancelled, right? Because here also time, here also time. Both the units are going to get cancelled. Anyway, you are going to get the same solution. So what is the average value? Average value is equal to 4 volt is the correct solution of this question. See, instead of doing all these things, we can solve this question in a very fraction of second also. What is the average value? Average value is nothing but area by total time. Area by total time. What is the area in the first half cycle? This area is nothing but 14 into 1. 14 into 1. And the second, in the remaining half cycle, what is the area? Minus 6 into 1. By total time it is 2. So 14 minus 6 by 2, that's it. 8 by 2 is nothing but 4. So, but this is the actual procedure. Suppose if the signal is somewhat difficult, then you have to go for the standard procedure. But if it is very easy, means you can directly find the area by time period. You can get the solution. But if it is a complex waveform, then you have to write the expressions for different time period and you have to solve it, then you are going to get the solution. So always you have to remember the average value is equal to integration of 0 to t, capital T, f of t dt by t, capital T, and RMS value is equal to integration of 0 to capital T, f of t whole square dt by capital T. So these formulas always you have to keep in your mind. So definitely, then only you can get the solutions. So this is the correct solution of this question. So now we are going to solve another question. See the question here. What are the poles and zeros of a system having the following transfer function? So what are the poles and zeros of a system having the following transfer function? So basically they have given some system transfer function and they're asking what are the poles as well as zeros for this transfer function. They're asking this question. So what is h of z? It is 1 minus z to the power of minus 2 by 1 plus 1.3 into z to the power of minus 1 plus 0.36 into z to the power of minus 2. So this is h of z expression, or we can say the transfer function of some descriptive system they have given. And they're asking what are the zeros as well as the poles. They're asking this question. So the four options, option A, which is the zeros are minus 1 comma plus 1 and the poles are minus 0.4 comma minus 0.9 is the correct solution of this question. So let's solve this numerical. As you can see clearly, what is h of z? The transfer function of the descriptive system they are given 1 minus z to the power of minus 2 by 1 plus 1.3 into z to the power of minus 1 plus 0.36 into z to the power of minus 2. So if you simplify means z to the power of minus 2 means 1 by z square, z to the power of minus 1 is 1 by z. So if you simplify, what you are going to get? You are going to get simply. So what I am trying to tell you, suppose if you simplify like this, 1 minus 1 by z square by 1 plus 1.3 by z plus 0.36 by z square. So if you simplify, in the numerator the LCM is z square and in the denominator the LCM is z square, then what you are going to get? Z square minus 1 by z square you are going to get. Similarly here, z square plus 1.3 into z plus 0.36 by z square. So z square cancels. So finally we are going to get like this, which is z square minus 1 by z square plus 1.3 z plus 0.36 that we are going to get. So let me rub this part. So this is what that we are going to get after doing the simplification, right? So now what I will do, listen carefully. This is the h of z they have given. That's that we got, which is z square minus 1 by z square plus 1.3 z plus 0.36. Z square minus 1 means 1 square. So z square minus 1 square nothing but a square minus b square square a plus b into a minus b. So z plus 1 into z minus 1 by. So 0.36, how I can write 0.36 nothing but, so 4 9s are 36, right? 4 9s 36. So 0.36 means 0.4 into 0.9. That's it. So 4 9s are 36, right? But I want 0.36 means 0.4 into 0.9. Then I am going to 0.36. So if you do the addition of these two things, then you are going to get 1.3 because 0.4 plus 0.1 is nothing but 1.3 and 0.4 into 0.1 is nothing but 0.36. So if you simplify, what we are going to get? We are going to get like this, z square plus 0.4 z plus 0.9 z plus 0.36. So in the first two terms take that as a common, so z plus 0.4. In the second two terms take 0.9 as a common, then we are going to get z plus 0.4. In the remaining two terms I can take z plus 0.4 as a common, then we are going to get z plus 0.9. So this is what we are going to get. Finally, h of z is equal to z plus 1 to z minus 1 by z plus 0.4 to z plus 0.9. So the numerator roots are called as zeros and the denominator roots are called as the poles. So the numerator roots are called as the zeros and the denominator roots are called as the poles. So what are the zeros? Plus 1 and minus 1. And what are the poles, which are minus 0.4 and minus 0.9. So therefore, the numerator roots of the transfer function are called as the zeros and the denominator roots of the transfer function are called as the poles. So zeros are minus 1 and plus 1 and the poles are minus 0.4 and minus 0.9. So this is the correct solution of this question. So now we are going to solve another question, which is the question here. How much is the energy of the discrete time signal x of n given by x of n is equal to minus 0.5 to the power of n into u of n, where u of n is the unit step sequence. Listen carefully. How much is the energy of the discrete time signal x of n given by x of n is equal to minus 0.5 to the power of n into u of n, where u of n is the unit step sequence. So what is the meaning of this one? What is the meaning of this? Means they are given some discrete time signal, they are given x of n. So they are given discrete time signal x of n, they have given, and they are asking what is the amount of energy which is going to present in this discrete time signal that we need to figure out. So basically they are given a discrete time signal which is x of n is equal to minus 0.5 to the power of n into u of n, they are given, and they are asking what is the amount of energy which is going to present in this discrete time signal we need to figure out, where u of n is the unit step sequence. So the four options, option C, 4 by 3 is the correct solution of this question. So this much amount of energy is going to present in this signal. So let's solve this numerical. So now what is x of n they have given? Minus 0.5 over the power of n into u of n. So this is the discrete time signal they have given. And I have already told you what is the expression of the energy in the discrete time sequence. The discrete time domain E is equal to sigma, n is equal to minus 70 plus mod of x of n whole square. So E is equal to sigma, n is equal to minus 70 plus mod of x of n whole square. So now what I will do, mod of x of n is nothing but as there is no imaginary part, take as it is. If it's imaginary part, must take the magnitude. As there is no imaginary part, take as it is. So therefore what we are going to get? Minus 0.5 over the power of n into u of n whole square. Right? Then we are squaring on both sides, then what we are going to get? Minus 0.5 over the power of u n into u of n whole square. Sigma is from n is equal to minus 70 plus infinity. As u of n is defined only from n is equal to 0 to infinity. So from minus 70 to minus 1, its value is equal to 0. So therefore this summation is now will become from n is equal to 0 to infinity. So sigma n is equal to 0 to infinity, and this value is nothing but 1. So 1 square is equal to 1. This value is nothing but same this value, just minus 0.5 on the power of pn. So now what I will do, I will simply substitute the value of n is equal to 0 and n is equal to 1 and n is equal to, then what I am going to get? Let us see. Suppose n is equal to 0 means anything power of 0 is nothing but 1 place. If substitute n is equal to 1 means you are going to get minus 0.5 whole square. If substitute n is equal to 2, then we are going to get minus 0.5 on the power of 4, and it goes on up to infinity. And I've already told you one important formula, which is we know that in a geometric series, when a plus ar square plus ar cube up to infinity is equal to a by 1 minus r, when the amount of the r is less than 1. So this formula, as I've already told you in the case of geometric series, which is a plus ar square up to infinity, its value is equal to a by 1 minus r when amount of the r is less than 1. This formula I've already told you. So this is the formula that you have to keep in your mind in the geometric series, which is a plus ar square up to infinity is equal to a by 1 minus r, where the amount of the r is less than 1. So from this, by comparing this, what I can say, a is equal to 1 and r is equal to minus 0.5 whole square, because a is equal to 1 and ar is equal to minus 0.5 whole the power of square. So by saying this, what is the value of r? R is nothing but minus 0.5 whole square. So a is equal to 1 and r is equal to minus 0.5 whole square. This substitute here a by 1 minus r, and you can see clearly what is the amount of r. So amount of r is nothing but minus 0.5 whole square. So r is nothing but minus 0.5 whole square. So minus 0.5 whole square is nothing but you can say minus 5 by 10 whole square. So 5 ones are 5 twos are. So minus 1 by 2 whole square, it is nothing but 1 by 4. As 1 by 4 is less than 1 by, so amount of r is less than 1. Yes, we got this condition. So this is going to satisfy the condition also. So what is the summation? We are going to get a by 1 minus r. A is equal to 1 and r is equal to minus 0.5 whole square. So if you substitute, then what we are going to get, which is equal to 1 by 1 minus this minus 0.5 whole square is nothing but 1 by 4. So 1 by 4. If you solve this one, what we are going to get finally 4 by 4 minus 1, which is nothing but 4 by 3. So 4 by 3 joules is the correct solution of this question. So this much amount of energy is going to present in the signal. So 4 by 3 joules. We have to write the unit also, because the energy unit is the joules. So this much amount of energy is going to present in the signal. So this is the correct solution of this question. So always you have to keep in your mind the energy expression is equal to signal is equal to mass into personality mod of x over whole square. Suppose if you want to write in the discrete Fourier transform, it will be equal to 1 by 2 pi integration of omega is equal to minus pi to plus pi mod of x of omega, or you can write mod of x of e to the power of j omega, also you can write whole square into d omega. These formulas just now we have discussed. As we don't need the discrete Fourier transform, we need only this value, so we have used this formula to solve this question. So finally I can say the amount of energy which is going to present in the signal is nothing but 4 by 3 joules. So this is the correct solution of this question. We are going to discuss another question. See the question here. The Laplace transform of the signal x of t is equal to minus into e to the power of minus 2t into u of minus t is. Where u of t is the unit step signal. For describing this question, they are given a signal x of t which is equal to minus into e to the power of minus 2t into u of minus t, and they are asking what is the Laplace transform of the signal x of t. We need to figure out. So the four options, option B, which is 1 by s plus 2, is the correct solution of this question. So let's solve this numerical. So as you can see clearly, for the signal u of t, what is the Laplace transform? As I already told you, for u of t, the Laplace transform is 1 by s. As u of t is a right-sided signal, so ROC is always stored the right side, which is sigma greater than 0. And for u of minus t, what is the Laplace transform? 3 plus t by minus t. So whenever we are going to replace t by minus t, then replace s by minus s, then we are going to get minus 1 by s. As it is a u of minus t is a left-sided signal, so ROC is toward the left side, which is sigma less than 0. So these two basic formulas always you have to keep in your mind. So with the help of this equation, we are going to write this one. Means I am going to multiply minus on the both sides. Then what I am going to get? Minus into u of minus t as the Laplace transform 1 by s. The ROC will never change. The ROC will never change because it will remain as it is. Just we are doing the multiplication of minus on the both sides. So ROC is not going to get affected. So therefore we are going to get the signal which is the one. So for minus into u of minus t, the Laplace transform is 1 by s with an ROC sigma less than 0. So now for this signal, I am going to multiply by e to the power of minus 2t. I have already told you whenever you are going to multiply by e to the power of minus 18 means replace s by s plus a. So here replace s by s plus 2. That's it. So here wherever s is there, replace s by s plus 2. So 1 by s plus 2. Here I can write like this. Sigma means real part of s. The real part of s is less than 0. So here replace s by s plus 2. So the real part of s plus 2 is less than 0 means sigma plus 2 is less than 0. So sigma less than minus 2. So this is the ROC. So therefore, minus into u to the power of minus 2t into u of minus t is the Laplace transform 1 by h plus 2 with an ROC sigma less than minus 2. So this formula always you have to keep in your mind. So therefore we can say that finally for the signal x of t which is equal to minus into the power of minus 2t into u of minus t, the Laplace transform is 1 by h plus 2 with an ROC sigma less than minus 2. Let me give you some important formulas. For f of t, if the Laplace transform is f of s with an ROC, the real part of s. Then f of at as the Laplace transform which is 1 by mod a into f of s by a, and the ROC is v plus s by s by the real plus s by s by a, that's it. So the real part of s by a. Then a can be either positive or a can be either negative. So let me write this one also. So a can be either positive or a can be either negative. Similarly, in the power of minus 18 f of t as a Laplace transform, the real plus s by s plus a, that's it. So f of s plus a. So ROC will become the real part of s plus a. These things always we have to keep in mind. So therefore we can say that for f of t, the Laplace transform is f of s, the ROC is the real part of s. Then for f of t, the Laplace transform is 1 by mod a, f of s by a, means replace s by s by a, replace s by s by a. So therefore ROC is the real part of s by a. And in the power of minus 18 to f of t, as the Laplace transform f of s plus a with an ROC, the real with an ROC which is the real part of s plus a, means replace s by s plus a, where s is there, replace s by s plus a. So finally, for this given signal x of t, what is the Laplace transform? 1 by s plus 2 with an ROC sigma less than minus 2. But in the question they have not asked about the ROC, but if they ask you, they can write like this, which is sigma less than minus 2 also. They are going to write the ROC. So option B is the correct solution of this question. So now we are going to solve the another question. See the question here. The amplitude spectrum, which is the magnitude of the x of j omega of a real signal x of t is. So basically what they are asking, the amplitude spectrum, which is the magnitude of the x of j omega of a real signal x of t is, they are asking this question. So if you see clearly what they have said, suppose they have taken x of t, which is a real signal they have considered. So x of t is basically, it is a real signal they have considered. And x of j omega is nothing but it is a Fourier transform of the signal x of t. So amplitude spectrum is the magnitude of the Fourier transform. So what is that we need to figure out? So our four options, option A, which is an even function, is the correct solution of this question. So it is always an even function, or we can say this symmetric with respect to y-axis. So what they have taken is very simple. Suppose x of t is a real signal, then x of j omega is called as the Fourier transform of the x of t, and it has a complex number, it has magnitude as well as a phase angle. So magnitude is called as the amplitude spectrum, then it is always a even function, whereas a phase angle, which is basically an odd function. But let me discuss in a very detailed manner. But out of the four options, option A is the correct solution of this question. So as you can see clearly, as x of t is a real signal. So as x of t is a real signal, as I have already told you, x of t is a continuous time signal. So this is called the continuous time Fourier transform. This is nothing but x of omega or x of j omega. You can keep it anything, x of omega or x of j omega, anything you can keep. So as it's a complex number, it has a real part as well as the imaginary part. It is a complex number, so it has a real part and the imaginary part. So what is the magnitude? Magnitude is nothing but magnitude of x of j omega, which is basically an even function. Whereas the phase angle of x of j omega is an odd function. So this is an odd function. So this is the thing that you always have to keep in your mind. So the magnitude of the x of j omega is always an even function, and the phase angle of h of j omega is called the odd function. So magnitude of x of j omega is also called as the amplitude spectrum. It is also called as the magnitude spectrum of amplitude spectrum, where the angle of x of j omega is called as the phase angle spectrum. So magnitude spectrum or the amplitude spectrum of a real signal is always an even function. Let me prove this one also. Let me prove to you with a small example. Suppose if you take x of t, which is a e to the power of minus 80 into u of t. So this is nothing but this is a real signal because there is no imaginary term. So that is the reason this is called as a real signal. And also, if you see clearly, as time goes on, the signal is going to get decay. So it is you can say it is an energy signal. It is an energy signal because the signal is absolutely incurable. So the given signal is a energy signal. So Fourier transform is a well-defined Fourier transform is for each and every value of omega, we are going to get some finite value of x of j omega. So therefore we can say this is a well-defined Fourier transform. So you can use you can use direct form, which is x of omega is equal to integration of t is equal to minus 70% x of t into the power of minus j omega t into dt. You can use that formula in order to get the Fourier transform for this signal. And if you figure out finally, you are going to get the Fourier transform, which is x of j omega is equal to 1 by a plus j omega. So now I want to find only the magnitude part. Only the magnitude part I want to figure out, which is magnitude of x of j omega is equal to 1 by under root of h plus omega square. And if you replace omega by minus omega, then what you are going to get? Then you are going to get 1 by under root of h plus minus omega whole square, which is nothing but 1 by under root of h plus omega square. So you can say magnitude of x of j omega is equal to magnitude of x of minus j omega. So therefore we can say it is an even function, or we can say it is a symmetric with respect to y-axis. Suppose if I want to draw the graph, how the graph is going to get look, see it carefully. So and if you substitute omega is equal to 0, you are going to get its value is equal to 1 by a. As omega increases, the value is going to get decreases. So like this you are going to get. So this is the symmetric with respect to y-axis, right? This is the graph. It is symmetric with respect to y-axis. So this is the magnitude spectrum. This is the magnitude spectrum. Whereas the phase angle spectrum is a odd function. Is a odd function that you can see clearly here. So therefore finally I want you to remember only one thing. When x of t is a real signal, the amplitude spectrum or the magnitude spectrum is always an even function, whereas the phase angle spectrum is always an odd function. This point always you have to keep in your mind. So this is the correct solution of this question. We are going to solve another question. See the question here. Which of the following discrete time system is not causal? So which of the following discrete time system is not causal? So basically this question they are given 4 options, and out of these 4 options, which discrete time system is a not the causal system? They are asking this question. So the 4 options, option is the correct solution of this question. So let's solve this numerical. So basically the first system that they are given, which is y of n is equal to x of minus n, is the relation between the output and the input for a given system, which is y of n is equal to x of minus n. Suppose if I substitute n is equal to minus 1, then what I am going to get? Y of minus 1 is equal to x of 1, means you can see, and t is equal to, the output at t is equal to minus 1 is depending on the input at t is equal to plus 1, means future input. So since the output is going to depend upon the future values of the input, so the given system is said to be non-causal. So what is the meaning of causal? Causal system means if the present output is independent of the future values of the input, then we say that the given system is said to be causal system. Otherwise, it is a non-causal system. So listen carefully. If the present output of the system is independent of the future values of the input, then the given system is said to be causal system. Otherwise, it is said to be a non-causal system. So in this case, as the present output is going to depend upon the future values of the input, so the given system is said to be a non-causal system. So now the other system is, the second system is y of n is equal to sigma k is equal to minus f to n x of k. So y of n is equal to sigma k is equal to minus f to n x of k. Suppose if you want y of 1 means it can take all the input from minus f to 1 only. So what it is going to include all the past values of the input, also the present values of the input, but now the future values of the input. The given system is said to be causal system. Since the output is going to independent of the future values of the input, so the given system is said to be causal. Now the option C, we can say the third system, which is y of n is equal to x of n minus 1. Suppose if I substitute n is equal to 1, then what I am going to get? Y of 1 is equal to x of 0 means the present, means we can say that the output is independent of the future values of the input, so the given system is said to be it is said to be causal system. Since the output is independent of the future values of the input, so the given system is said to be causal. Now let's go for the system D. For a system D output input into equation y of n is equal to y of n minus 1 plus x of n. So how can I write y of n? Y of n I can also write, which is sigma k is equal to minus m to n x of k, because I can write like this one, right? So this I can write up to sigma k is equal to minus m into n minus 1 x of k, and the end term I can write x of n. So this is nothing but y of n minus 1 and this is x of n. So therefore you can write y of n is equal to y of n minus 1. This x of n you can write like this, please. Y of n is equal to sigma k is equal to minus into n x of k. So you can say clearly, as discussed, we have discussed, as the present values of the output is depending only on the process of the input of the present values of the input, but not on the future values of the input. So the given system is said to be causal system. As the output is independent of the future values of the input, the given system is said to be causal. So if you see clearly, system B, system C, and system D, all these are the causal systems, whereas the system A is only a non-causal system. So in this question, they're asking out of this, which system is a non-causal system means, or not a causal system means, option A is the correct solution of this question. So finally, I want to tell you one important statement, which is a system is said to be causal if the present value of the output is independent of the future values of the input. So, otherwise, it is called as the non-causal system. So this point always you have to keep in mind. So option A is the correct solution of this question. So like this, always you have to keep in mind each and every statement. Now let's go for the other question. See the question here. The fundamental period n of a discrete time signal e to the power of j into 3 by 4 into n is. The fundamental period n of a discrete time signal e to the power of j into 3 by 4 into n is. So basically, they have given some discrete time signal. They have given some discrete time signal. They have given. Basically, we can say this is a discrete time complex signal because a complex term is there. So we can say this is a discrete time complex signal. Discrete time is here, n is there. Then it is a discrete time. Here j is there, so it is a complex signal. So combination of these two is nothing but discrete time complex signal. So for this discrete time complex and is also periodic signal, then what is the fundamental period we need to figure out? So the four options, option D, n is equal to 8 is the correct solution of this question. So let's solve this numerical. So now we are going to solve this question. What is the signal they have given? X of n is equal to e to the power of j into 3 by 4 into n. So what is the signal? The signal is nothing but it is a discrete time. It is a discrete time. It's a discrete time complex signal. It's a discrete time complex signal. Why it is like this? Because n is there. That is the reason it's a discrete time and there is a j. So that is the reason it is called as a complex. So overall it is called as a discrete time complex signal. So you know the general format. What is general format? E to the power of j omega t, or in the continuous time case, or e to the power of j omega. Sorry, e to the power of j omega n. This is a standard. This is a standard expression that continuous time domain and this is a standard expression in discrete time domain. So by comparing, we can say omega is nothing but 3 by 4. Omega, you know, 2 pi by n. In the case of discrete time case, it will be 2 pi by n. So, but so some of the books they are going to write 2 pi. 2 by n. Okay, let's go for 2 by n. Okay, 2 by n is equal to 3 by 4. 3 by 4. So if you simplify what pi cancels, we are going to get 2 by n is equal to 3 by 4. And what is the value of n? N is equal to 8 by 3. We are going to get. But 8 by 3 is nothing but it is not an integer. It is not an integer. So definitely we should get a integer value only. So we should get a integer value only, but not the fraction. So 8 by 3. So if you multiply by 1, then what are you going to get? 8 by 3. This is not an integer. Similarly, the next number is 8 by 3 into 2 is something but this is also not an integer. Again, I multiply by another number, then what you are going to get? 8. So this is the integer. So this is the fundamental period. So this is the fundamental period. So always, whatever the number that you are going to get, if it is not an integer, means you have to multiply by integers until you are going to get a fundamental, until you are going to get it, until you are going to get some integer value. So I have multiplied until 1, 2 and 3. So finally after multiplying 3, I got a integer. So that is the reason this is called as a fundamental period. So this is called as a fundamental period. So n must be always an integer. So therefore n is equal to 8 by 3 into 3, which is equal to 8. So 8 is the correct solution of this question. So what I am trying to do is very simple. Suppose we got some value and that may not be an integer. So you have to multiply by the integer values starting from 1, 2, 3 and goes on. So if you are going to multiply, then if you are going to get a integer, then stop it. That is called as the that we are going to call it as the simply the period. So, but in some books what they are going to do, let me write here. In some books what they are going to do is very simple. What we got omega, right? Omega is equal to 3 by 4 we got. For example, what they are going to take, omega is nothing but 2 pi m by n they are going to consider. Theta by 4. So if you simplify, what you are going to get? 2m by n is equal to 3 by 4. So n is equal to 8 by 3 into m, they are going to get here. M is always an integer starting from 1, 2, 3 and goes on. Suppose if you substitute m is equal to 1, then what you are going to get? 8 by 3. If you substitute m is equal to 2, then we are going to get 16 by 3. If you substitute m is equal to 3, we are going to get 8. So therefore, this is the fundamental period because it should be always an integer. So this is the correct solution. So what I am trying to do is very simple. We have to multiply by the integer starting from 1, 2, 3 and 2 so on until we are going to get the integer for the period. So n is equal to 8 is the fundamental period of this segment. So this is the correct solution of this question. So now we are going to solve another question. See the question here. Phase function of a filter is phi of f is equal to k into f square, where k is greater than 0. Where k is greater than 0. The group delay of the filter as the shape. So listen carefully. The phase function of a filter, they are given phi of f is equal to k into f square, where k is greater than 0. Then what is the group delay of the filter? The group delay of the filter as the shape. So if you see clearly what they have mentioned, then some filter is there. For that, what is a phase function? It is a function of frequency which is k into f square and k is greater than 0 that they already mentioned. Then what is the group delay of the filter? Expression or the shape that we need to figure out. If you know the expression, you can draw the graph, right? So what is that shape we need to figure out? So what are the 4 figures? Option is the correct solution of this question. So this is the option is the correct solution of this question. So let's solve this numerical. So now, as you can see clearly, what is the meaning of phase function? Phase function, generally, I have already told you the formula. Phase function is nothing but where we have taken phase angle of h of omega. But here they have given which is equal to 5, they have mentioned. And I have already told you how to remember the formula. Post graduation. The shortcut is PG. PG is the post graduation. First you are going to get P, then you are going to get G. So this is the shortcut I have already told you, right? The first thing that you are going to get is a post graduation is PG. So first you are going to get PT, then PG. PT means phase delay and TG means group delay. So this formula I have already told you. PT is equal to minus of phase angle of h of omega by omega and TG is equal to minus of d by d omega of the phase angle of h of omega. This formula I have told you so many number of times, right? So many number of times I have already told you. So TT is equal to minus of phase angle of h of omega by omega and TG is equal to minus of d by d omega of phase angle of h of omega. This is a formula I have already told you. But here the phase angle is nothing but just 5 they are mentioned. So instead of phase angle of h of omega, I am going to replace phase angle of h of omega by 5. Therefore, we are going to get here minus 5 by omega and minus d by d omega of 5. So what is 5 expression? 5 they are given is equal to k f square they are given and k is greater than also k is greater than 0 that they are already mentioned. And what is the TG we need to find? What is the group delay time that we have to figure out? Not the phase delay, but we have to find the group delay, which is TG we need to figure out. So in the formula TG is equal to minus P by either you can write d omega or either you can write df. And here which is same because here phi is not a function of omega because omega means you have to do the division with respect to omega. But here in this case it is with respect to frequency, right? So it is with respect to frequency. So I will take here df. So minus d phi by df. So minus d by df of what is 5 k of square. So k is a constant, take it outside. So minus k into derivative of x3 is equal to pf. So minus 2 kf we are going to get. Then what is TG? TG is equal to minus 2 kf. When k is greater than 0, we already mentioned. So k is greater than 0 means what is the value that we are going to get? So TG is equal to minus 2k into f. So as k is greater than 0, so minus into 2k is nothing but it is a negative. So this is called as a fluid. We know y is equal to mx, right? So y is equal to mx, y is equal to TG and m is equal to f4. Sorry, x is equal to f4. So m is equal to minus 2k. Slope is equal to negative that we are going to get. So slope is equal to negative. So therefore, if you are going to draw the graph between the TG and f, TG is plus the group delay. So you are going to get a straight line passing through origin with a negative slope. Positive slope means in this direction, negative slope means in this direction. So this is a y is equal to mx means with a straight line passing through origin with a negative slope. So the slope is nothing but a minus 2k as you can see clearly and k is greater than 0. So Tg is called as a root delay. So I want you to remember these two formulas, which is the we can say phase delay, and then comes the root delay. Phase delay is nothing but minus of phase angle of h of omega by omega, whereas Pg is the minus of d by d omega of phase angle of h of omega. So these two formulas always you have to keep in mind, and the shortcut remember is the Pg. First comes the T, then comes the G, which is post graduation. So Tp and then comes the Pg. These two formulas always you have to keep in your mind. So what's the graph that we are going to get? This graph. So this is a Pg, this is a F. So with the negative slope. So this is the correct solution of this question. Now we are going to solve another question. See the question here. The RMS value of the periodic waveform as shown in the figure is. So what is the RMS value of the periodic waveform as shown in the figure? So they have given a signal x of t is a periodic signal. As you can see clearly, the signal has a period of t because the same cycle is going to repeat again after a period of time. So that is a reason this is a periodic signal. And from 0 to t by 2, it is like a triangular waveform. And from t by 2 to t, it's having a constant value of minus a. So for this waveform, for this periodic waveform, we have to find what is the RMS value. So here the peak value is a, here also the peak value is minus a. So under 4 options, option B, under root over 2 by 3 into a is the correct solution of this question. Means it is like this, which is equal to under root over 2 by 3 and a is outside. So this is the correct solution of this question. So let's solve this numerical. So this is the signal x of t. Same graph I have drawn. Same graph I have drawn. So you can see it is like a ramp signal from 0 to t by 2. And it is having a peak value of a at t by 2. And from t by 2 to t, it is having a value of minus a. So after a period of time t, same signal is going to get repeated. So we have to find what is RMS value of the signal. So basically in the given time period t, I want to write what is the expression of the signal x of t. X of t is what is the slope here? Here the height is a. Here it is a t by 2. So what is the slope? A by t by 2 is nothing but 2a by t into small t. So 2a by capital T into t, which is y is equal to mx. Slope is nothing but 2a by t. And the x is nothing but here t. Y is nothing but x of t. So x of t is equal to 2a by t into t. This is the expression for t less from 0 to t by 2. And from t less from 3 by 2 to t, what is the value of x of t is equal to minus a. So we have two expressions, right? So x of t is equal to 2a by capital T into t for t less from 0 to t by 2. And from minus t by, from plus t by 2 to t, its value is equal to minus a. So for the signal, we have to find what is the RMS value. So RMS value is nothing but x of t RMS is equal to under root of 1 by t into integration of 0 to t x of t whole square dt. So this formula is already told you. Then what is the average value? Average value means x of t average value is nothing but it is equal to 1 by t into integration of 0 to t x of t dt. So these formulas are already told you so many number of times. So x of t RMS is equal to under root of 1 by t into integration of 0 to t x of t whole square dt. Then basically we have x of t. We have two different equations of x of t for different times. So we are going to do integration from 0 to t by 2, then t by 2 to t. From 0 to t by 2, what is the expression of the x of t? Is equal to 2 by capital T into t. And from t by 2 to t, what is the expression of x of t, which is minus a. So I have substituted here. So 1 by t, integration of 0 to capital T by 2, 2a by capital T into t whole square dt plus integration of p by 2 to t minus a whole square into dt. So if you simplify, 2a by t whole cube is nothing but 2a by t whole square is nothing but 4a square by t square. And integration of t square is nothing but t cube by 3. So t cube by 3, the limits 0 to t by 2 plus minus the whole square is nothing but a square. Integration of the dt is nothing but t. Substitute the limits t by 2 and t. So upper limit minus lower limit, if you simplify, what we are going to get under root of 1 by t into 4a square by t square into upper limit minus lower limit. So t by 2 whole cube by 3. So t by 2 whole cube is nothing but t cube by 8 into 3 plus a square into upper limit minus lower limit t by t minus t by 2 is equal to t by 2. So if you simplify, what I can say, here t square is there, here t cube is there. So they are going to get cancelled and we are going to get t here. Similarly, here 4 ones are 4 twos are, so 3 twos are 6. And here a square t is there. So 1 by under root over 1 by t into a square t by 6 plus a square t by 2. So what is the LCM? 2, 6 is equal to 6. So LCM is 6 here, a square t plus 2 3s are, so 3 a square t. So 3a square t plus a square is nothing but a square is a 4a square t by 60. So 3 cancels. 2 2s are 2 3s are. So therefore, what we are going to get finally, which is equal to under root over 2 by 3 a square. So a square is going to come outside. So therefore, finally we are going to get under root over 2 by 3 into a. So under root over 2 by 3 into a is the correct solution of this question. So under root over 2 by 3 into a is RMS value of the signal x of t. So this is the correct solution of the question. So this is a very basic question. I am going to explain more and more. But I want you to remember only these two formulas, that always for a given signal x of t, what is the average value? So x of t average is nothing but, which average is equal to 1 by t into integration of 0 to t x of t dt. Similarly, what is the RMS value? X of t RMS value is nothing but, which is equal to 1 by t under root over 1 by t into integration of 0 to t x of t whole square into dt. So these two things always you have to keep in your mind. So x of t RMS is equal to 1 by t into integration of 0 to capital T x of t dt, and x of t RMS is equal to under root over 1 by t into integration of 0 to capital T x of t whole square dt. So these two formulas always you have to keep in your mind. So this is the correct solution of this question. So now we are going to solve the other question. See the question here. The Laplace transform of the x of t found by this convolution operator is. So basically what they are asking this question, the Laplace transform of x of t is formed by the convolution operator. So what is the x of t? They have given p into u of t convolution of cos 2 pi t into u of t. So for this signal x of t, it's a convolution of two different signals. One is p into u of t and the other is cos 2 pi t into u of t. Then what is the Laplace transform of the x of t? We need to figure out. So there are four options. Option A, which is 1 by s into a square plus 4 pi square, is the correct solution of this question. So let's solve this numerically. So here, let me tell you in detail regarding everything. Suppose x1 of t, I am going to do the Laplace transform. Then we are going to get x1 of s with an ROC 1. For x2 of t, what is the Laplace transform? S2 of s with an ROC 2. Suppose if you are doing a convolution in the time domain, it will become the product in the Laplace domain. So x1 of t convolution of x2 of t as a Laplace transform x1 of s into x2 of s with an ROC. The common ROC of these two things, or the intersection ROC of these two different ROC, which is ROC1 intersection ROC2. It means whatever the common thing is going to present in these two ROCs, that is going to become the resultant ROCs for this signal. So the convolution is in the time domain is going to become the product in the Laplace domain. So for t into u of t, what is the Laplace transform? 1 by s square with an ROC signal greater than 0. And for cos 2 pi t into u of t as a Laplace transform, s by s square plus a square. You know, cos a t into u of t as a Laplace transform, s by s square plus a square. A is equal to 2 pi. So therefore we are going to get s square plus 2 pi whole square with an ROC sigma greater than 0. Then ROC sigma greater than 0. Then t into u of t convolution of cos 2 pi t into u of t as a Laplace transform, which is the product in the convolution in the time domain is going to be the product in the Laplace domain. So do the multiplication of the corresponding Laplace transform, which is 1 by s square into s by s square plus 2 pi whole square. What is the resultant ROC? The resultant ROC is nothing but it is a common ROC. As this is sigma greater than 0 and this is sigma greater than 0. So what is the common ROC between these two ROCs, which is sigma greater than 0? So here basically we can say here s cancels. We are going to get finally x of it is nothing but 1 by s into s square plus 4 pi square with an ROC is sigma greater than 0. So what is x of t? X of t is nothing but t into u of t convolution of cos 2 pi t into u of t. For this signal, what is the Laplace transform x of s, which is equal to 1 by s into s square plus 4 pi square with an ROC sigma greater than 0. See, I want you to remember the two important formulas, which is cos omega t into u of t as the Laplace transform s by s square plus omega square with an ROC sigma greater than 0. Similarly, t to the power of n into u of t as the Laplace transform, and we can say n factorial by s to the power of n plus 1 with an ROC sigma greater than 0. So these things always you have to keep in your mind. So therefore we can say for cos omega t into u of t as the Laplace transform, which is s by s square plus omega square with an ROC sigma greater than 0. And for t to the power of n into u of t as a Laplace transform n factorial by s to the power of n plus 1 with an ROC sigma greater than 0. By using these two formulas only, we have got this one. So whatever the convolution of time domain is going to become the product in the Laplace domain. So just we did the product of the corresponding Laplace transform of the signal, and then we got the expression, and the ROC is the common ROC of these two different signals. So finally, option is the correct solution of this question. But if they ask you about the ROC also means what is the result of the ROC, which is sigma greater than 0, as you can write here. So this is the correct solution of this question. So now we are going to solve another question. See the question here. The question says that the function f of t has the Fourier transform g of omega. The Fourier transform of g of t is, so the function f of t has the Fourier transform g of omega. Then what is the Fourier transform of the g of t? We need to figure out. So if you see clearly what they have mentioned, suppose they have taken a function f of t and they have to its Fourier transform, we are going to get g of omega. Then what is the Fourier transform of the g of t? We need to figure out. So the four options, option C, 2 pi into f of minus omega is the correct solution of this question. So let's solve this numerical. So basically what they're saying is very simple. Suppose for f of t, what is the Fourier transform? The Fourier transform is nothing but g of omega. Then for g of t, what is the Fourier transform they are asking in this question? So out of the four options, option C is the correct solution of this question. So let's solve this numerical. So what is the solution here? Listen carefully. Now this is basically with the help of duality principle, and we are going to solve this question with the help of duality principle. As I already told you, suppose f of t has a Fourier transform, small f of t has a Fourier transform capital F of omega, then capital F of t has a Fourier transform 2 pi into small f of minus omega. This formula I have already told you so many number of times. So small f of t has a Fourier transform capital F of omega, then capital F of t has a Fourier transform 2 pi into small f of minus omega. This principle I have already told you so many number of times. So this is regarding the duality theorem. But in this question what they have mentioned, suppose if small f of t has a Fourier transform small g of omega, then small g of t has a Fourier transform 2 pi into small f of minus omega. That's it. Here you replace omega by t here. Here multiply 2 pi and replace t by minus omega. So therefore we are going to get 2 pi into f of minus omega. So this is a basic formula. With the help of this basic formula only, we have got this solution. So the duality principle says that if f of t has a Fourier transform, if small f of t has a Fourier transform capital F of omega, then capital F of t has a Fourier transform 2 pi into small f of minus omega. So what is the meaning, basic meaning of this one? Suppose if you take some signal in the time domain and you are going to get the Fourier transform graph in the frequency domain. Suppose if this graph, if the frequency domain graph, if it is coming in the time domain, then what is the corresponding frequency domain graph that we need to figure out? So listen carefully. Suppose this is a time domain graph, Fourier transform is we are going to get some graph in the frequency domain. Suppose if this graph is going to come in the time domain, then this graph is going to come in the frequency domain with the multiplication of 2 pi. So this is what I am trying to tell you. Suppose if this graph is going to come in the time domain, then this graph is going to come in the frequency domain with the multiplication of 2 pi and replacing omega by replace t by minus omega. So these things I already told you so many number of times. So in simple words I can say like this. In simple words I can say, if this graph is going to come here, then this graph is going to come here. Listen carefully. If this frequency graph is going to come in the time domain, then this time domain graph is going to come in the frequency domain. Listen carefully. But there is some type of scaling factor is there. So listen carefully. If the time domain graph and the frequency domain graph, they are going to become reverse. Yes. If time domain graph is going to come in frequency domain, means the frequency domain graph is going to come in the time domain graph. That is the meaning of this expression. So if the time domain graph is going to come in the frequency domain, then the frequency domain graph is going to come in the time domain. Means reverse thing. So but it's an amount of scaling factor. So you can see clearly from this expression. So this is the correct solution of this question. The answer is 2 pi into f of minus omega is the correct solution of this question. And these two formulas that you always have to keep in mind, because in examinations they are going to ask questions from this concept. So I have given like this. Suppose if you take a rectangular pulse, it is having an amplitude of t it is having a width of t. This is t by 2 and this is minus t by 2. This is a time domain, a rectangular pulse. This is x of t and this is t. So what is the corresponding Fourier transform? X of omega is equal to, the formula is area into saw of omega into width by 2. Area into saw of omega into width by 2. Area is nothing but A into T. Omega into what is the width of T? So T by 2. AT into saw of omega into T by 2. Psi is nothing but I already told you. saw of x is equal to sin x by x, and sec of x is equal to sin pi x by pi x. I've already told you that saw of x is equal to sin x by x, and sec of x is equal to sin pi x by pi x. So if you see these two things, what I can say, that is sec of x is equal to saw of pi x. If you replace x by pi x, and both are going to become same. So sec of x is equal to saw of pi x. Suppose if you take a triangular pulse, in the time domain, then what is the corresponding frequency transform? So the Fourier transform I want to figure out. So you can say this is a, here with is 2t, here amplitude is a. X of what is the Fourier transform? X of omega is equal to, here the formula is area into saw square into omega into width by 4. Area into saw square into omega into width by 4. So here what is the area? Half into base into height. So half into base is 2t into height is a. So 2t cancels, we are going to get a into 2. Saw square into omega into what is the width here? 2t. So 2t by 4 is nothing but t by 2. So 80 into saw square into omega into t by 2. So for the rectangular pulse, the Fourier transform is area into saw into omega into width by 2. Whereas for triangular pulse, the Fourier transform is area into saw square into omega into width by 4. These two things always you have to keep in your mind. And saw of x is equal to sin x by x, and sec of x is equal to sin pi x by pi x. By seeing these two things, we can say sec of x is equal to saw of pi x. And saw is nothing but sampling function. Saw means it is a sampling function. So these things always you have to keep in your mind here. So this is the correct solution of this question. So this is the correct solution of this question. This 2.2 small f of minus omega is the correct solution of this question. So now we are going to solve another question. See the question here. The impulse response of a linear time invariant system is h of n is equal to 1, 2, 1, minus 1. The response for the input signal x of n is equal to 1, 2, 3, 1 is. So listen carefully. The impulse response of a linear time invariant system is h of n is equal to 1, 2, 1, minus 1. And the response for the input signal x of n is equal to 1, 2, 3, 4. 1, 2, 3, 1 is. So basically they have taken a LTI system as linear time invariant system. For this system they are given impulse response h of n they are given, and also input also they are given. Then what is the corresponding output we need to figure out. So the four options C, which is 1, 4, 8, 8, 3, minus 2, minus 1 is the correct solution of this question. So let's solve this numerical. So what is the signal x of n they are given? S of n is equal to 1, 2, 3, 1 they are given, and also the impulse response for this LTI system, which is h of n is equal to 1, 2, 1, minus 1 they are given. And I've already told you in the case of LTI system, what is the output? The output is equal to combination of the input as well as the impulse response. So let me draw the graph here. So this is the LTI system. For the LTI system, the impulse response is h of n, or the input is x of n. And what is the output here? The output is nothing but y of n. So y of n is equal to x of n, convolution of the h of n. Right? So basically now we have to do the convolution. So convolution we can do with two methods. One is the tabular method and the other is a conventional method. So tabular method only now we are going to solve. So you can take x of n here, or either you can take x of n here. You can take in any. First just we are going to do this by tabular method. Basically there is also one more method, and that is called as a conventional method. But conventional method that we are not going to do. But conventional method means x of n will become delta of n plus 2 delta of n minus 1. Like that we are going to write, but that we are not going to consider because it will take a lot of time. So instead of that we go for a tabular method. The tabular method is very simple, which is simply, see, x of n you can take it here, or either you can take it here, or h of n you can take it here, or you can take it here. So basically in this I will take x of n. So in this I will take the x of n values which are 1, 2, 3, 1. In this I will take x of n values which are 1, 2, 1, minus 1. Then do the multiplication. 1 to 1 is 1, 1 into 2 is 2, 1 into 1 is 1, 1 into minus 1 is minus 1. So 2 into 1 is 2, 2 2s are 4, 2 1s are 2, 2 into minus 1 is minus 2, 3 into 1 is 3, 2 into 2 is 6, 3 into 1 is 3, 3 into minus 1 is minus 3. So 1 into 1 is 1, 1 into 2 is 2, 1 into 1 is 1, 1 into minus 1 is minus 1. So now we have to draw lines like this. Here 1 line, here 2 line, here 3rd line, here 4th line, here 5th line, here 1 line. Means in the first line we will take only one element, then 2 elements, then 3 elements. Here the same, 1 element, 2 element, 3 element. Then comes the finally fourth element. So you have to take first element here, here also first element. Here 2 elements is, here also 2 elements. Here 3 elements means here also 3 elements. Like that you have to do the lines. Now do the addition. Now do the addition of all the elements. This will become 1 as it is. 2 plus 2 is 4. 3 plus 4 plus 1 is nothing but 8. 1 plus 6 plus 2 plus minus 1 which is 8. 2 plus 3 plus minus 2 is equal to 3. 1 plus minus 3 is nothing but minus 2. Then comes the minus 1. So you have to take the values from top to bottom. From top to bottom. Like this you have to take the values. So in this direction you have to constant the values. So in this direction you have to constant the values and you have to write in this way. So you have to transfer all the values from in this direction. From this direction we have to take all these values in this one. So y of n is nothing but 1, 4, 8, 8, 3, minus 2, minus 1. So this is the y of n that we are going to get. So this is the correct solution of this question. So I want you to remember only one thing, which is these are the values of the y of n. So we can solve the convolution by two methods. One is the tabular method and the other is the conversion method. Conversion method, now we are going to study because it will take a lot of time. So instead of that, we will go for the this one. We will go for this one. But I want to tell you some important points regarding this one, which is some important thing that you have to keep in your mind. So if you want to find, so I've already told you, y of n is nothing but x of n combination of h of n. So one point I want to tell you, sigma of y of n is nothing but sigma of x of n into sigma of h of n. Sigma means addition. So if you do the addition of all these elements, what you are going to get of y of n? 1 plus 4 is 5. Plus 8 plus 8 is 16, right? Plus here minus 2 minus 1 is minus 3. Minus 3 plus 3 is nothing but 0. So 5 plus 6 is nothing but we are going to get 21 we are going to get. So this value is 21. Then do the addition of sigma of x of n, do the addition of all the values of x of n. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 1 is equal to 7. So you are going to get this value is 7. And similarly do the h of n sigma. 1 plus 2 is 3, 3 plus 1 is 4, 4 minus 1 is 3. So you are going to get 3. So do the multiplication of these two things. 7 3 is 21. 7 3 is 21. Yes, 7 3 is 21. So this is 7 and this is 3. So this is 21. So this formula you have to remember, which is if y of n is equal to x of n, let me write here. So if y of n is equal to x of n combination of h of n, then sigma of y of n is nothing here. Sigma of x of n into sigma of h of n. Similarly, suppose if y of t is equal to x of t combination of the h of t, then area under the y of t graph is equal to area under the x of t graph into area under the h of t graph. So this is a two important things always we have to keep in your mind. If y of n is equal to x of n combination of h of n, then sigma of y of n is equal to sigma of x of n into sigma of h of n. Similarly, if y of t is equal to x of n combination of h of n, then area under the y of t graph is equal to area under the x of t graph into area under the h of t graph. So these 2 points always you have to keep in your mind. So this is the correct solution of this question. So now we are going to solve another question. So the question here, the z transform of the x of n is x of z, then the z transform of x of n minus a is. So basically for x of n, the z transform is x of z, and for x of n minus a, what is the z transform we need to figure out. So the 4 options C, z to the power of minus k into x of z is the correct solution of this question. So let's solve this numerical. So basically this is a time shifting property. This is a time shifting property, as I already told you. If x of n has z transform x of z, then x of n plus or minus k as z transform to the power of plus or minus k into x of z. Here plus means here plus, here minus means here minus. That's it. So this is a time shifting property. Here plus means here plus, here minus means here minus. So this is a bilateral z transform or two-sided z transform. So x of n as z transform x of z, then x of n plus or minus k as z transform z to the power of plus or minus k into x of z. So in this case, they are given x of n minus k. So minus means what you are going to get? X of n minus k means what is z transform? X to the power of minus k into x of z. That's it. This is the formula. This is the thing that we are going to get here. So let me tell you some important formulas. So for delta of n, for the delta of n, what is the z transform? X value is equal to 1. and it is all over the ROC is all over the Z plane, means it is defined for each and every value in the Z. So for delta of n, the ROC, the Z transform is 1 and its ROC is all over the Z plane. And a to the power of n into u of n as Z transform Z by Z minus a, as a to the power of n into u of n is a resident signal, so its ROC is outside the circuit is mod n greater than mod a. Then a can be the positive or a can be negative or a can be a complex number. Similarly, minus into a to the power of n into u of minus n minus 1. Listen carefully, minus into a to the power of n into u of minus n minus 1 as Z transform same as it is with Z by Z minus a. Minus is a left sided signal, so its ROC is inside the circuit is mod z less than mod a. Then a can be the positive, a can be negative or a can be complex number. So these things always you have to keep in your mind. So a to the power of n into u of n as Z transform Z by Z minus a with an ROC mod z greater than mod a. A can be positive, a can be negative or a can be complex. Similarly, minus into a to the power of n into u of minus n minus 1 as Z transform Z by Z minus a with an ROC mod z less than mod a. Where a can be positive, a can be negative or a can be complex. And let me tell you some more formulas also. If f of n as Z transform f of z with an ROC mod z, then f of minus n as Z transform f of z inverse. So if you are going to replace n by minus n means replace z by 1 by z. Then replace z by 1 by z means here also replace in ROC also replace z by 1 by z means to the power of minus 1, not to the power of minus 1. Similarly, here n into f of n. So n into f of n, what is z transform minus z into df of z by dz, and the ROC is same as it is. The ROC will never change. So this ROC and this ROC will never change. Same ROC is going to get present. So if f of n as z transform f of z with an ROC mod z, then f of minus n as z transform f of z to the power of minus 1 means whenever you are going to replace n by minus n, then replace z by 1 by z. So in the ROC also replace z by 1 by z. So you are going to get mod of 1 by z or mod of z to the power of minus 1. Similarly, n into f of n as z transform minus z into df of z by dz. But the ROC is same as it is. Whatever the ROC in this case, same thing we are going to get. The ROC will be same. It will never change. So this is the third solution of this question.